If you are preparing for the PMI-CP exam, chances are you already have strong construction experience. Yet many experienced professionals fail or feel uncertain walking into the exam. Not because they lack knowledge, but because the exam is not testing knowledge alone. It is testing how you think, how you decide, and how you act under governance, contracts, and real construction constraints. This course is built to close that gap. The PMI-CP exam is not asking what you would do on site instinctively. It is asking what the most appropriate action is when authority is limited, contracts apply, risks are shared, and formal processes matter. Most wrong answers sound practical. The correct answer follows governance, contracts, and professional judgment. This course trains you to recognize that difference quickly and confidently. Real-world experience can sometimes work against you in the PMI-CP exam. In practice, you may solve problems quickly to keep the project moving. In the exam, that same action may be wrong if it bypasses authority, contracts, or escalation paths. This course helps you recalibrate your thinking from what works on site to what the exam expects from a construction professional. This course does not just explain topics, it changes how you read questions. You will learn how to identify what the question is really testing, how to eliminate distractor options, and how to select the most appropriate action based on project phase, authority, and governance. This approach improves speed, accuracy, and confidence under exam pressure. You will learn how the PMI-CP exam tests construction communication, not as soft skills, but as governance tools. We focus on how communication failures occur between clients, consultants, contractors, and suppliers, and how structured escalation and authority influence the correct response. This is one of the most underestimated areas in the exam. A large portion of the PMI-CP exam revolves around scope control, contracts, risk allocation, and interfaces. This course breaks down how scope changes become claims, how contracts drive risk ownership, and how interface failures between disciplines create delays and disputes. You will learn how these topics are connected and how the exam expects you to manage them as a system, not as isolated issues. Governance and professional judgment are the hidden thread running through the entire PMI-CP exam. Many questions across different domains are testing the same thing. Do you recognize authority, follow formal processes, and act ethically under pressure? This course trains you to spot governance signals instantly and respond correctly. By the end of this course, you will not just know the content. You will have a clear strategy for reading questions, a consistent decision-making framework, and the confidence to choose the best answer without second-guessing yourself. If you are serious about passing the PMI-CP exam and understanding how it truly evaluates construction professionals, this course is designed for you. Let's begin. Domain 1 represents a significant 50% weighting of the PMI-CP exam, making it the most critical pillar of your preparation. Our objectives today are designed to give you the highest return on your study time. First, we are going to master the risk process. The exam expects you to prioritize risk identification specifically during front-end planning, or FEP. If you see a question where a project is failing in the construction phase, the correct answer often points back to a failure in the FEP phase. Second, we will look at how to allocate liability. This is where we apply the golden rule of allocation. Understanding this rule is your primary defense against the disputes and claims that plague the built environment. Moving into the technical side, our third objective is to apply technical tools. You must be able to distinguish when to utilize the Integrated Project Risk Assessment, the IPRA, versus when to deploy a Monte Carlo simulation. These are Task 2 requirements that test your ability to choose the right tool for the right scenario. Finally, we will master exam logic. Many students fail not because they don't know the material, but because they can't distinguish between an immediate action and an analysis step in a scenario-based question. We will break down that logic so you can choose the most professional response every time. With these objectives in mind, let's look at how the PMI-CP context redefines our traditional understanding of project risk. Think about the last time a project went over budget. Was it because of a threat that no one saw coming? Or was it because someone was forced to pay for a mistake they didn't have the power to prevent? In the PMI-CP context, we define risk as physical, financial, and, most importantly, contractual. There is a major mental shift required here. We are moving from the generic project management goal of mitigating threats to the specific construction goal of allocating liability. This brings us to the golden rule of the built environment. This rule states that risk must always be allocated to the party best positioned to manage, control, or insure against it. For example, the contractor is best positioned to manage site safety, while the owner is best positioned to manage the risk of obtaining project funding. When we ignore this rule, we face the consequence. Look at the visual of the seesaw. When the allocation is inappropriate or unbalanced, it creates a contingency loading effect. If an owner tries to push all the risk onto a contractor, the contractor will simply increase their bid costs to cover that potential liability. This results in higher costs for the owner and inevitably an adversarial relationship where both parties spend more time documenting claims than building the project. By understanding this balance, we can avoid the pitfalls of high bid costs and litigation. This leads us to ask, when is the most effective time to achieve this balance? The answer lies in the front-end planning phase. If you discover a soil condition issue during the construction phase, the cost to fix it is astronomical compared to discovering it during the planning phase. This is the logic behind Task 1 of the PMI-CP, Managing Risk Prioritization During Front-End Planning, or FEP. Look at the graph on this slide, which is a classic representation of project influence. The blue line shows your ability to influence risk. Notice how it is at its absolute peak during the planning and FEP phases, but then drops off a cliff as we move into design and construction. Conversely, the orange line shows the cost of change. It starts low, but skyrockets the moment operations begin. This is why the exam focuses so heavily on FEP. If a risk is discovered late, like those unexpected soil conditions, the exam logic dictates that the root cause was a failure in the FEP phase. Here is a key exam tip for you. When you are faced with a scenario-based question about a project in trouble, look at the options carefully. If an option suggests revisit FEP documents or consult the FEP risk register, it is very often the correct governance step. It demonstrates that you understand the point of high leverage. You aren't just reacting to the fire, you are looking at why the fire was allowed to start in the first place. Now that we understand when to assess risk, let's look at a specific tool designed for this high leverage phase, the IPRE. What do you do when a project is so complex that a simple spreadsheet isn't enough to capture the risks? This is where the Integrated Project Risk Assessment, or IPRA, comes into play. You should think of the IPRA as a health check for a project's readiness. The IPRA is a structured tool specifically used to assess risk on complex projects with a heavy focus on scope definition and readiness. On the exam, you need to know exactly when to use it. If a scenario implies uncertainty about whether a project is actually ready to move out of the planning phase and into detailed design or bidding, the IPRA is your go-to tool. It helps the project team identify definition gaps before they become change orders. When you are reading exam questions, keep a sharp eye out for specific keywords. If you see terms like scope maturity, readiness, gate reviews, or definition gaps, the exam is signaling that an IPRA is the appropriate technical response. It's not just about listing risks. It's about scoring the project's maturity to ensure it can survive the next phase. While the IPRA focuses on scope and readiness, our next tool focuses on the mathematical reality of uncertainty, the Monte Carlo simulation. Have you ever been asked exactly when a project will finish, and you gave a single date only to be proven wrong 2 weeks later? This is the danger of deterministic thinking. The PMI-CP exam wants you to move toward probabilistic thinking using Monte Carlo simulations. The goal here is to drive a better risk process by calculating probability distributions for both schedule and cost. Instead of a single point, we look at a range. Look at the curve on the slide. A P50 represents 50% confidence, essentially a coin flip. In the professional built environment, we aim for high confidence targets, typically P85 or P90. For the exam, you must distinguish between these two approaches. Avoid the deterministic trap. Saying the project will finish on May 1st is a high error statement. Instead, adopt the probabilistic approach. There is an 85% probability the project will finish by May 15th. This range provides a much more accurate picture of reality. In an exam application, these simulations are your best tool to justify the value of contingency reserves to stakeholders. When a sponsor asks why you need a certain amount of extra funding, you point to the P85 distribution to show the statistical necessity of that reserve. Speaking of uncertainty, it's important to remember that not all uncertainty is bad. Let's look at how to recognize positive risks. Most people hear the word risk and immediately think of something going wrong. But in the professional world of construction, risk is simply uncertainty that matters. And sometimes that uncertainty can be beneficial. These are called opportunities. On the left side of our scale, we have threats, which we manage by mitigating, avoiding, or transferring. But on the right side, we have opportunities. Our strategies here are different. We seek to exploit, share, or enhance them. Let's look at some real-world construction examples. Exploiting an opportunity might mean adding extra resources to a task because you've realized you can capture an early completion bonus. Sharing often appears in the form of a value engineering clause, where the owner and contractor agree to split any savings found during construction. Here is your exam insight. If you encounter a scenario involving favorable conditions, like unexpectedly good weather or a sudden drop in material prices, don't look for mitigation in the answers. Instead, look for enhance or exploit. The exam is testing whether you can recognize when to lean into a positive situation to create more value for the project. Now that we've covered the theory and the tools, let's put your knowledge to the test with a real-world exam scenario. Let's walk through a scenario you are very likely to see in some form on the PMI-CP exam. Imagine you are the project manager for a major highway expansion. Your contractor is excavating when, crunch, they hit a utility line. This line was not shown on any of the municipal drawings provided during the tender phase. Immediately, the contractor submits a change order to cover the costs of the delay. However, the client refuses to pay. They point to a verify site conditions clause in the contract, claiming it was the contractor's job to check the ground before digging. This is a classic deadlock situation. The contractor feels it's an unknown, while the client feels it was verifiable. The question asks, what is the most appropriate immediate action? Option 1 suggests rejecting the change order immediately to protect the budget. Option 2 suggests instructing the contractor to repair the line at their own cost to keep the schedule moving. Option 3 involves reviewing the contract's differing site conditions clause and the risk register to determine liability. And Option 4 suggests a total stop work order until all drawings are updated. Take a moment to think. Which of these is the most professional, governance-first response? We will analyze the correct path on the next slide. In the previous scenario, the tension was high, but as a PMI-CP certified professional, your first instinct must always be governance first. The correct action is Option 3. Review the contract's differing site conditions clause and the risk register. Why is this the only professional answer? The rationale is simple. You must analyze before you act. You cannot legally or ethically accept or reject a claim until you verify the contractual allocation of unknown versus verifiable site conditions. Let's look at why the other options fail. Option 1, immediate rejection, is a hot-headed move that leads straight to disputes and expensive arbitration. Option 2, forcing the contractor to pay, is even worse. If the contract actually states that the owner is responsible for unmapped utilities, you are damaging the relationship and likely violating the contract. Option 4, the stop work order, is an overreaction that creates unnecessary delay costs. The takeaway for your exam is this: always establish the contractual fact pattern before making any financial decisions. If you haven't checked the rules of the game, the contract, you shouldn't be making a move. This concept of analyze before acting is so important that it forms the basis of our next logic lesson. One of the most common traps on the PMI-CP exam is the first versus next question. You will often see 4 options that are all technically correct things to do, but only one of them is the chronological first step. To navigate this, follow the 4-step ladder shown on this slide. Step 1 is analyze and verify. This involves checking the contract, inspecting the site, or gathering data. Step 2 is evaluate. This is where you assess the specific impact on scope, cost, and schedule. Step 3 is collaborate, having those necessary discussions with stakeholders. Only then, at step 4, do you act by issuing a variation or a change order. The rule you must memorize is never act before you analyze. If an answer choice says issue a change order and another says review the impact, the review must come first. The exam is testing your discipline as a manager. Are you someone who reacts to the loudest person in the room, or are you someone who follows a structured governance process? This logic applies to everything, especially when deciding which contract type to use for a project. Choosing the right contract type is essentially the act of choosing who will carry the risk bag. On one end of the spectrum, we have the fixed price, or lump sum, contract. Here, the contractor bears almost all the risk. If the project costs more than expected, the contractor eats that cost. Because of this, you should only use fixed price when the scope is perfectly defined. Using this for an undefined project is a recipe for massive claims later. On the other end, we have cost plus, or reimbursable, contracts. In this scenario, the owner bears the risk. They pay the contractor for every dollar spent, plus a fee. This is ideal when the scope is evolving or undefined, but it requires very strict audit governance so the owner doesn't get taken advantage of. In the middle, we find unit price contracts. Here the risk is shared. The owner takes the volume risk. They pay for however many units are actually used, while the contractor takes the rate risk. They must stick to their price per unit regardless of market changes. The exam logic here is vital. Using a lump sum contract on a project with an undefined scope isn't just a bad idea. It's a failure of risk management under Task 1. Now, let's look at a different kind of risk that happens when you have multiple contractors working together. Here's another high-probability exam scenario involving interface conflict. Imagine you are managing a large program with multiple prime contractors. You have a civil package contractor and a mechanical package contractor. The situation turns sour when the civil contractor is delayed. Because they haven't finished their work, the mechanical contractor can't get onto the site. Now, the mechanical contractor files a claim against the owner for idling resources. They are paying for crews and equipment that have nowhere to work. The question asks, how should this situation have been prevented during planning? Option 1, stricter penalty clauses for the civil contractor. Option 2, implementing an interface management process to map handoffs. Option 3, using a cost-plus contract for everyone. Option 4, forcing the mechanical contractor to work night shifts. This scenario tests your understanding of root cause versus symptom. Penalties and night shifts are reactions. but we are looking for the planning phase prevention. Let's break down the interface management solution. In the previous scenario, the correct action was Option 2, implementing an interface management process. This is a key focus of Domain Y, Task 5. The rationale is that the claim for idling resources is just a symptom. The root cause is a lack of coordination between separate packages. In a multi-contractor environment, risk management requires you to map interface points, or IPs, before a single person arrives on site. Look at the diagrams on the slide. Interface point A, B, and C represent the literal and figurative handoff points where one contractor's work meets another's. Why are the other options wrong? Stricter penalties, like those in option 1, might make you feel better, but they don't actually prevent delays. They only punish them after the damage is done. Interface management, however, is proactive. It forces the contractors to talk about the gaps in the schedule before they become claims. On the exam, if you see a multi-prime contractor scenario, always look for interface management as the strategic solution. Now let's move from managing people to managing the money, specifically our reserves. One of the most frequent points of confusion for candidates is the difference between contingency and management reserves. To the exam, these are two very different safes with different keys. The contingency reserve is for known unknowns. These are risks you actually identified and wrote down in your risk register. Because these are expected possibilities, this money is included in your cost baseline. As the project manager, you usually have the authority to use this money when an identified risk occurs. The management reserve fund, however, is for unknown unknowns. These are completely unforeseen events, black swan events that no one could have predicted. This money is not in your cost baseline. If you need it, you must go to senior management or the project sponsor for approval. Watch out for the exam trap. If the question states that a risk was already identified in the register, the funding must come from the contingency reserve. If you choose management reserve in that scenario, you are telling the examiner that you don't understand basic financial governance. Think of the contingency reserve as your project wallet and the management reserve as the bank's vault. Finally, let's summarize everything we've learned about Domain I. We have covered a lot of ground today, and mastering these 5 pillars will put you in a very strong position for the 50% weighting of Domain Y. First, remember the context. Construction risk is fundamentally contractual. You must distinguish between physical safety and contractual liability. Second, remember timing. Front-end planning is your point of high leverage. If you are looking for where a project went wrong, start there. Third, know your tools. Use the IPRE for scope readiness and Monte Carlo for probabilistic schedule and cost distributions. Fourth, uphold governance. Always analyze the contract and the facts before you act on a change order or a claim. And finally, manage interfaces. On projects with multiple contractors, an interface management plan is your primary tool for preventing idling resource claims and handoff failures. By applying this logic, governance first, probabilistic thinking, and proactive planning, you aren't just preparing to pass an exam, you are preparing to lead complex projects with confidence. Would you like me to generate a set of practice quiz questions based on these specific scenario-based logic rules? Have you ever stood on a multi-million-dollar job site and realized that despite having the best engineers and the highest grade materials, the project was still paralyzed because 2 key stakeholders simply weren't on the same page? This is the core challenge of our lecture today on why communication fails. In the built environment, communication is not a soft skill. It is a technical project control, just as critical as schedule management or cost estimation. We are here to perform a formal diagnostic and remediation session for project managers and construction engineers. In construction, a misunderstood sentence isn't just a social awkwardness, it is a catalyst for financial disaster. If an instruction is vague, it leads to rework. If a rework occurs, the profit margin disappears. If the margin disappears, the project fails. This module, focused on governance and communication, is designed to give you the tools to treat communication as a formal project control. We will explore the financial impacts of these failures, diagnose systemic gaps in contracts, and provide the remediation strategies necessary to protect your project's budget and schedule. We aren't just here to talk about being nice. We are here to talk about being effective. By the end of this session, you will see communication as the glue that holds the various technical components of a project together. Let's begin by examining our specific learning objectives to ensure your study path is aligned with the rigorous standards of the industry. By the end of this lecture, you won't just be a better communicator, you'll be a more effective governor of project information. Our goals are specific and measurable. First, you will learn to analyze the tangible financial and schedule impacts of poor communication, specifically focusing on the concept of the cost of rework. You need to be able to quantify exactly how much money is walking out the door every time an RFI is ignored or an email is misunderstood. Second, we will identify the root causes of failure by distinguishing between macro, or systemic factors, and micro, or interpersonal factors. Third, you will gain the ability to differentiate between conflict and dispute in a contractual context. This is a critical distinction for management. Conflict is a risk that can be mitigated, while a dispute is an issue that often requires formal legal resolution. Fourth, you will learn how to select the appropriate governance document for specific scenarios, knowing when to use a transmittal versus a submittal or a formal change order. Finally, we will apply the 7 principles of effective communication to mitigate the inherent vagueness found in construction contracts. Each of these objectives represents a brick in the wall of professional governance. If you master these, you will become a manager who prevents claims before they ever happen. Our first step in this journey is understanding the fundamental power of communication as a leadership mechanism for coordination. In the context of the built environment, communication is the primary mechanism for a project manager to coordinate work across diverse and temporary teams. We look at this through several professional pillars. The first pillar is transmission. In a professional leadership setting, the sender holds the sole responsibility for ensuring the message sent is exactly the message received. This is the path toward achieving universal understanding. If there is a breakdown in communication, a leader doesn't blame the listener. They adjust the transmission. The second pillar is building trust. Construction projects are unique because they involve disparate contractors who may have no prior history. Effective communication fosters the social capital necessary to bridge these gaps. Third, we must recognize the silent signal. In leadership, silence is an action. If you fail to communicate about a priority, that silence signals to your team that the task isn't important. Finally, we have medium selection. While face-to-face meetings allow us to read body language and build rapport, the contractual nature of our industry mandates written confirmation for all official actions. You might agree to a change in the field with a handshake, but it isn't real until it's documented. This understanding of leadership power is the foundation for avoiding the high costs associated with communication failure. Communication is the tool that transforms a collection of individual contractors into a cohesive project team. Let's look at the hard data behind communication failure. Industry research suggests that the annual cost of rework in the construction industry is a staggering $17 billion in the US alone. When we look closer at that number, we find that a massive 50% of all that rework is attributed directly to poor communication and faulty project information. That means billions of dollars are being wasted, not because we can't build, but because we can't communicate what to build. Furthermore, 70% of projects experience significant delays due to these exact communication issues. We can break this down into a cause and effect relationship. The causes often include a lack of effective communication between parties, a lack of shared platforms, poor interpersonal skills, language barriers, and using improper channels, like using a personal text message to authorize a structural change. The effects are cost overruns, time overruns, legal disputes, and the constant need for redesign. Most critically, there is a direct correlation between poor communication and a high accident rate. When a safety warning or a coordination detail isn't transmitted effectively, people get hurt. This is why communication is a safety issue, not just a financial one. To combat these effects, we rely on a specific set of legal and governance documents that serve as the project's single source of truth. To govern a project effectively, you must understand the backbone of construction control, the legal and governance documents. First are transmittals, which serve as the cover sheet. A transmittal is legal proof of what was sent, who received it, and exactly when action is required. If a dispute arises regarding whether a contractor received the latest revision of a drawing, the transmittal log is your primary defense. It turns he said, she said into a matter of documented fact. Next, we have the contracts. This is your primary point of control. Contracts define legal obligations and are essential for avoiding the high-risk environment of verbal agreements. A good contract must be clear, concise, and binary, leaving no room for maybe. Third, we have warranties, which focus on quality. These are obligations regarding the longevity of the finished product, and they can be explicitly issued or implied by law. Finally, we have estimates. Before execution begins, the estimate establishes the work volume and the budget plan. These documents set the rules of the game. However, once the site is active, we move into a different set of documents designed to manage the day-to-day operational reality. Without these formal documents, a project is managed by luck rather than by governance. Operational documents are the tools you will use every single day to keep the project moving while managing risk. The first of these is the submittal, which is central to your quality assurance process. Submittals include shop drawings and material data. This is a governance check that allows you to ensure the correct products are being installed before it's too late to change them. If the submittal isn't approved, the material shouldn't be on the site. Next is the site diary, often called the log. This is a daily record of progress, weather conditions, and site incidents. In the event of a delay claim, the site diary is the primary evidence used to prove site conditions. Then we have change orders. These are vital because they register any changes in scope, schedule, or design. A change order directly affects liability and payment, so it must be handled with extreme care. Finally, we have memoranda, or MOUs. These document a willingness to move forward during complex negotiations without yet being a final contract change. Every professional must know which of these tools is the correct response for a specific situation. Let's put that into practice right now with an exam-style scenario that tests your ability to select the right document for a site challenge. Imagine you are the project manager for a commercial build. The electrical subcontractor comes to you and verbally informs you that the specified wiring is out of stock. They propose an immediate equivalent substitute that is in stock, and they emphasize that this change will not affect the project cost. What is the most appropriate governance action? This is a classic test of your commitment to formal project controls versus field expedient shortcuts. Option A suggests updating the site diary to authorize the install. Option B is to issue a transmittal to the client. Option C is to request a formal submittal, a material data sheet, for the new wiring for approval. Option D is to create a change order. The best action is C, request a formal submittal. The reasoning is essential. A site diary records events, but does not authorize technical changes. A change order is for cost or schedule impacts which aren't present here. Submittals are the specific governance mechanism to verify that materials meet requirements before installation. If you just authorize it verbally, you are assuming all the liability if that wire fails a later inspection or causes a fire. Proactive governance means using the right document at the right time. To solve a communication problem, you must first diagnose its scale. We categorize these failures into macro and micro scales. A macro failure involves the major project stakeholders, the owner, the client, and the lead consultants. The impact of a macro failure is typically severe, leading to high financial loss, major changes to the project scope, or total project failure. The root causes at this level are often contractual, systemic, or rooted in conflicting goals, where the parties aren't working toward the same outcome. On the other hand, we have the micro failure. This occurs between internal teams, specific trades, or individual employees. While the scale is smaller, the impacts are still dangerous. Micro failures lead to site accidents, rework, mistakes, and interpersonal friction. The root causes here are usually interpersonal conflict, a lack of clarity in instructions, or language barriers on a diverse site. As a project manager, your strategy depends on this diagnosis. You fix a macro failure through better contractual governance and systemic changes, but you fix a micro failure through better interpersonal leadership and clearer operational instructions. Understanding this scale helps you decide whether you are dealing with a simple difference of opinion or a dispute that requires formal legal resolution. One of the most critical concepts for management is the distinction between conflict and dispute. Think of this as the difference between a risk and an issue. A conflict is a difference of opinion or interest. At this stage, it is manageable and should be viewed as a project risk. Your action as a manager is to mitigate it before any damage occurs. Conflict is a natural part of a complex project where different parties have different interests. When a conflict is unmanaged and escalates, it becomes a dispute. A dispute is the equivalent of a manifested project issue. This means the situation has reached a point where it requires formal resolution. At this stage, you are no longer just managing it. You are moving into negotiation, mediation, arbitration, or even litigation. The impact of a dispute is that it prevents successful project completion and drains resources into legal fees. On an exam or on the job, if you see parties who disagree but are still communicating, you are in conflict. If work has stopped and formal claims are being filed, you are in a dispute. Your goal is to keep everything at the conflict level where you still have control. Most disputes begin as simple communication gaps in the original contract language. Why do so many projects start with a high-quality contract but still end up in a dispute? It usually comes down to 4 specific communication gaps. The first is a lack of clarity. This happens when parties sign a contract without clear goals or binary scope definitions. If the scope is vague, both parties will interpret it in a way that favors them. Second is the level of involvement. If you exclude key technical leads from the contract negotiations, your sales team might make unrealistic promises that the site team simply cannot keep. Third is the handoff gap. This is a classic failure where a sales team signs a deal and then hands it to the implementation team without a full transfer of knowledge. The remedy here is early involvement. Finally, we have vagueness. This is the dangerous use of words like may instead of must. In construction, may implies optionality. If a client expects a certain safety measure but the contractor views it as optional because the contract said may, a dispute is guaranteed. To prevent these gaps, we must adhere to the 7 principles of effective communication as our core standards. By closing these gaps, we ensure that the contract serves as a bridge rather than a barrier. To prevent project failure, every professional must adhere to these 7 communication standards. First, we have active listening. This means allowing others to speak and truly understanding their perspective before formulating your response. Second, we must be masters of asking questions, knowing when to use open questions to gather information and closed questions to get a firm yes or no commitment. Third, we must address conflicts head-on by finding their root causes rather than just treating the symptoms. Fourth, every communication must have a clear purpose. What are the deadlines? Fifth, every communication must have a clear outcome. Who has the responsibility? Sixth, we must avoid vagueness by prioritizing definitive words like must over the optional may. Finally, there is decisiveness. A project manager must be assertive. Assertive communication isn't about being aggressive. It's about being clear, firm, and focused on the project's requirements. These 7 principles act as the gears that keep the communication machine running smoothly. Without them, even the best planned project will eventually grind to a halt. Let's look at another scenario to see how one of these principles, avoiding vagueness, can be the difference between a happy client and a legal battle. Let's look at a scenario that tests your ability to diagnose the root cause of a conflict. The situation is this. A contract specification states, the contractor may provide dust control measures during demolition. Now that the project is active, the client is demanding dust control. However, the contractor refuses to provide it, stating it was never priced because the contract clearly made it optional. What is the root cause of this conflict? Option A suggests the contractor is being unprofessional. Option B says the client failed to inspect the site. Option C states that the project manager allowed ambiguous language, the word may, into the contract. Option D points to a handoff gap. The best answer is C. The reasoning is purely contractual. May implies permission, not obligation. Only words like must or shall create a legal obligation. Vagueness like this leads to scope gaps, where one party expects a deliverable that the other party never intended to provide. This is why your role as a governor of communication starts long before the construction begins. Now let's talk about how to keep these principles alive during meetings, which are often the most expensive part of a project manager's day. Meetings are a necessary part of project management, but they are also incredibly expensive. To prevent failure, meetings require strict governance. We follow the 24-hour rule for both preparation and execution. During preparation, the best practice is to circulate the meeting agenda at least 24 hours in advance. You must define your objectives clearly. Is this meeting for information sharing, or is it for decision making? If you don't know the objective, don't hold the meeting. Furthermore, control your attendees. Only invite decision makers or the technical experts required. During execution, use a timed agenda. Allocate specific minutes to each topic to ensure the conversation doesn't drift. A vital leadership tip is understanding that silence equals agreement in many contexts. As a leader, you must explicitly ask for dissent to ensure there are no hidden issues. Finally, the second half of the 24-hour rule. Meeting minutes and action items must be distributed within 24 hours of the meeting's conclusion. If the minutes aren't out in 24 hours, the decisions start to fade and people's memories of the agreements will differ. To help manage all this information, we turn to technology as our single source of truth. In the modern built environment, we use technology as a critical tool for governance. This starts with the PMIS, or Project Management Information System. There is a fundamental rule here. If a piece of information isn't in the PMIS, it isn't official. Centralization is our primary defense against version control errors, where people might be building off the wrong drawings. This system holds our daily logs, RFIs, and change orders. We also leverage BIM, or Building Information Modeling. BIM is a form of visual communication that allows us to identify clashes, like a pipe running through a structural beam, before construction ever begins. This saves millions in rework. We are also seeing the emergence of blockchain, which creates secure, immutable legal agreements and can serve as a trigger for payments. Whether it's daily logs or complex 3D models, these technological platforms ensure that everyone is working from the same facts. By using technology to maintain a single source of truth, you eliminate the he said, she said arguments that lead to disputes. Technology doesn't replace communication. It provides the infrastructure that makes effective communication possible. We have covered a lot of ground today, and mastering these 5 pillars of communication will be essential for your professional success. First, remember your leadership responsibility. As the project manager, you are the transmitter, and you must ensure the message sent is the message received. Second, maintain strict document governance. Use submittals for approval, transmittals for tracking, and change orders for managing shifts in liability. These are the tools that provide legal protection. Third, prioritize contract clarity. Remove words like may and should, and replace them with binary definitive language like must or shall. Fourth, always respect the distinction between conflict and dispute. Treat conflict as a preventable risk and a dispute as an issue that requires formal resolution. Finally, fix the handoff. Always involve your implementation and site teams during the contract negotiation phase to prevent knowledge gaps. By treating communication as a technical discipline rather than an afterthought, you turn it from a project vulnerability into a powerful engine for success. Communication is the foundation of all project governance. Would you like me to walk you through a specific case study where a handoff gap led to a major contractual dispute so you can see these principles in action? Welcome to this specialized deep dive into Module 4 of your professional certification journey. Today, we are focusing on one of the most underestimated yet highest leverage aspects of construction management: building communication strategy and plans. In the high-stakes world of complex infrastructure and global mega projects, communication is not merely about sharing information. It is about constructing a rigorous governance structure that serves as a primary risk mitigation tool. As we begin, it is vital to adjust your mindset. In many professional circles, communication is dismissed as a soft skill. However, for a certified construction professional, it is a hard project control, just as critical as your structural calculations or your cost-loaded schedule. A failure in communication at the mega project level is rarely a simple misunderstanding. It is a breakdown in the project's central nervous system. This module is designed to give you the blueprint for preventing those breakdowns. We will explore how to establish a vision for information exchange before the first contract is signed and how to maintain that vision through years of site work, technical challenges, and inevitable stakeholder turnover. We will look at how to build resilience into your project information systems so that when a crisis hits, and in construction, a crisis always hits, your team doesn't scramble to find a spokesperson or an approval channel. Instead, they follow a predefined, proactive protocol that protects the project's reputation and legal standing. By the end of this session, you will be equipped to architect the flow of data for projects of any scale. Let's move to our roadmap for this session and look at the learning objectives we intend to master. Our roadmap for this intensive module is built around 4 critical learning objectives that are essential for both passing your exam and succeeding in the field. First, you will learn to distinguish between a communications strategy and a communications management plan. On the exam, these are 2 distinct entities with different birth dates and different purposes. You will learn to see the strategy as your blueprint, the overarching why, and the plan as your map, the tactical how and when. Second, we will identify the 7 principles of effective communication strategies. We will place a massive emphasis on the day 1 requirement. You will learn why starting your communication strategy after the RFP stage is considered a foundational failure in project governance. Third, we will perform a deep dive analysis of feedback loops, specifically positive, negative, internal, and external loops. These are not just theoretical concepts, they are your verification mechanisms. You will learn how to use a negative feedback loop not as a tool for criticism, but as a technical tool for gap closing to ensure site work matches the specifications. Finally, we will apply this entire framework to resolve complex real-world scenarios. We will look at how to handle stakeholder turnover in the middle of a multi-year project and how to structure a crisis communication plan that remains proactive rather than reactive. Mega projects are marathons, and these objectives are designed to give you the stamina to maintain clear governance from inception to post-occupancy. Achieving these goals requires us to first acknowledge the massive financial reality of why we are here. To understand why we treat communication with such extreme technical rigor, we must look at the global economic landscape of the built environment. We are currently living in an era of unprecedented scale, where annual global megaproject spend has reached $9 trillion. To put that in perspective, that is roughly 8% of the entire global GDP. We are building bigger and more complex projects than ever before in human history. However, the performance data provided by the Project Management Institute is sobering. 99% of these massive projects fail to deliver on their original budget, their original schedule, or their intended benefits. When we perform a forensic analysis on why these projects fail, the data reveals a shocking truth. 33%, a full 1/3, of all megaproject failures are caused directly by ineffective communication. This is why the certification context demands that you view communication as a rigorous governance structure for risk mitigation. If 1/3 of our bridges were falling down due to bad steel, we would change the steel specifications immediately. In this case, the steel of our projects is the information flow. When you sit for the exam, you must remember this 33% statistic. It serves as your justification for why you must invest time and budget into a formal communication strategy at the very start of the project. We are not just talking about avoiding missed emails. We are talking about preventing the systemic errors that lead to multi-billion-dollar losses and project cancellations. This leads us to our first major technical distinction, the difference between your strategy and your plan. A fundamental concept that appears throughout the certification materials is the clear technical distinction between a communication strategy and a communications management plan. The communication strategy is what we call the blueprint. It must be developed at day 1, specifically during the RFP or request for proposal stage. Its focus is on the why and the who. The strategy sets the high-level vision for how information will be exchanged and ensures that every major stakeholder has buy-in and awareness of the project scope from the very first meeting. The goal of the strategy is to promote the project and establish its value proposition to both the internal team and the external world. The communications management plan, on the other hand, is the map. This is developed later, during the build or detailed planning phase. Its focus is on the how and the when, the tactical execution of the vision established in the strategy. While the strategy provides the sense of order, the plan provides the specific behavior and targets. The plan is where we get into the nitty-gritty details. It defines specific messages, identifies the exact media channels to be used, and sets the timelines for every update. The plan also contains the RACI matrix, which identifies who is responsible, accountable, consulted, and informed for every piece of data. The logic you must carry into the exam is that strategy always precedes the plan. If the strategy is flawed or non-existent, the plan will fail regardless of how high the quality of execution is. You cannot have an effective map if you haven't first agreed on the blueprint of where you are going. When you're answering scenario-based questions on the exam, you will often be asked to identify whether a specific management action belongs in the strategy or the management plan. To get these questions right, you must ask yourself, what is this question actually asking me to achieve? If the question is focused on aligning high-level goals, understanding the broad contributions of different stakeholders, or establishing high-level oversight for a project, you are dealing with the communication strategy. It is the sense of order that keeps the project's purpose clear. If, however, the question is asking about the frequency of weekly reports, the specific file formats for CAD drawings, or identifying the owner who is responsible for delivering a specific site update, you are looking at the communications management plan. This is the domain of behavior and targets. Think of it this way. The strategy is the what and why, while the plan is the when and how. A common exam trap is to jump straight into how, to send a report before checking if the high-level why of that report has been strategically aligned. If a project manager starts sending dashboards without first verifying that the stakeholder wants dashboards, they have skipped the strategy phase and are inviting a communication failure. Always look for the option that establishes the strategic vision before committing to a tactical behavior. To build a strategy that can withstand the pressures of a multi-year construction project, you must adhere to 7 non-negotiable principles. Principle 1 is to start early. This is the day 1 requirement. Your strategy must be established at the RFP stage so that expectations are set before contracts are signed. Principle 2 is tailor to audience. You cannot send the same technical report to a structural engineer that you send to a local community leader. The language and focus must be customized. Principle 3 is bespoke design. You must avoid copy-paste management. Every project has a unique set of stakeholders, site conditions, and legal requirements. Principle 4 is careful planning with a laser focus on the project's specific goals. Principle 5 involves feedback loops. You must have a mechanism to verify that your messages are actually being understood and acted upon. Principle 6 is flexibility. This is one of the most important principles for the built environment. Because mega projects last for years, you must be able to adapt to stakeholder turnover. Your strategy is not a static document. It must evolve as leadership changes. Finally, Principle 7 is method variety. Do not rely on a single channel. Use a mix of digital dashboards, face-to-face site walks, and formal written memos to ensure the message sticks. If you miss even one of these 7 gears, the machine of your project communication will eventually seize up. Let's apply these principles to a realistic exam scenario. This is a situation that often confuses candidates who think too rigidly about the signed plan. Imagine you are the project manager for a 5-year rail project. You are currently in year 3. Suddenly, the transport minister, a key stakeholder and sponsor, is replaced. The new minister prefers detailed data dashboards for all project updates. However, the previous minister specifically wanted executive summaries, and your current communications management plan, which was signed by everyone 2 years ago, dictates that you only send executive summaries. The question asks, which action should you take first? Option 1 suggests continuing to send executive summaries exactly as the signed plan dictates to maintain consistency and follow the law of the project. Option 2 suggests immediately updating the plan to include the new dashboards and sending them to the minister. Option 3 suggests engaging the new minister directly to understand their full range of expectations and then updating the strategy accordingly. Option 4 suggests explaining to the new minister that the governance was fixed at the RFP stage and cannot be changed for the duration of the 5-year project. Take a moment to evaluate which of these follows the 7 principles of effective strategy. We will break down the professional logic and the correct answer on the next slide. The correct action in the previous scenario is option 3. Engage the new minister to understand their expectations and then update the strategy. This scenario is a direct test of principle number 6, flexibility. In the world of megaprojects, stakeholder turnover is a certainty, not a possibility. If your strategy is so rigid that it cannot adapt to a new sponsor, the project will lose political and financial support, which leads to failure. Let's look at the order of operations. In professional governance, the strategy, which represents expectations, always drives the plan, which represents tactics. You must validate the expectation first by engaging the new stakeholder. Option 2 is incorrect because it is purely reactive, changing your tactics, the dashboards, without first aligning on the strategic vision. The why is how errors and miscommunications occur. Options 1 and 4 are even worse because they represent rigidity, which we will later see is a common cause of project failure. Ignoring a new stakeholder's needs because of how we've always done it is an amateur mistake. On the exam, always pick the path that involves high-level strategic alignment before changing the day-to-day tactical behavior. This ensures that your management plan remains a living document that serves the project's current reality. Once the overarching strategy is established, we move into the detailed construction of the communications management plan. There are 8 key elements that must be present to ensure a single source of truth. First, you must identify target audiences using a RACI matrix, clarifying who is responsible, accountable, consulted, and informed for every piece of project data. Second, you must document stakeholder expectations gathered during the strategy phase. Third, you must select the specific tools and methods. Will you use a digital PMIS, standard email, or physical site boards? Fourth, define target messages so that the core project goals are never lost in the noise. Fifth is classification. You must distinguish between formal communication, like a change order, and informal communication, like a site conversation. Sixth, set the forms and frequency. How often are the meetings, and what is their purpose? Seventh, identify the owner. Who is the specific individual responsible for delivering the message? Finally, establish branding and style guides. This is critical for joint ventures to ensure a consistent legal and professional image. If multiple companies are working together, a consistent brand clarifies who has the liability for the information being sent. Without these 8 elements, your plan is just a list of ideas. With them, it is a powerful governance tool. Every major construction project will face a crisis, but only the well-governed ones have a plan for it. Consider the case study of the IRPTS project in Polokwane, South Africa. This was a massive infrastructure project designed to solve urban gridlock. Because the construction would cause significant traffic disruption and block access to local businesses, the project required a specific proactive crisis communication plan long before the first road was closed. The exam insight here is that crisis plans must be proactive, not reactive. You cannot wait for the crisis to happen to decide who speaks to the media. Your plan must define your protocols before the first incident occurs. It must include recovery steps, designate a single official spokesperson, and define clear approval channels for any information release. This is where governance becomes essential, especially in joint ventures. If a JV has 3 different partners, and they all start giving different stories to the press during a crisis, the project's liability and reputation will be devastated. Consistency in branding and messaging is your primary defense. On the exam, if a question asks about a crisis, the first step is always to follow the predefined protocol in the plan. In control theory and professional project management, a feedback loop is an iterative process where the output of a system is monitored to identify deviations, which are then fed back into the input to make corrections. We use 4 main types of loops to manage performance gaps. Positive feedback is constructive. It's about adding value to advance the project, essentially amplifying good work. Negative feedback is a tool for compliance and control. It's about identifying a gap or a defect that must be corrected to bring the project back to the plan. We also distinguish between internal and external feedback. Internal loops are like peer reviews or QA checks within your project team. External loops come from clients, government inspectors, or the public. For the exam, you must understand that these loops are your primary verification mechanisms. Without them, you are merely broadcasting information without knowing if it has been understood or acted upon. A feedback loop ensures that the message sent actually results in the action required on the job site. It turns communication into a closed-circuit control system that maintains project quality and schedule. Let's test your technical understanding of feedback theory with a common site scenario. Imagine the following situation. A routine site inspection reveals that the new HVAC ducting clashes with several lighting fixtures. The client notices the error and issues a formal notice of non-compliance. As the project manager, you immediately halt the installation and create a remediation plan to realign the ducting to the original specifications. From a professional perspective, what type of feedback loop is being utilized here? Option A, positive feedback loop. Option B, negative feedback loop. Option C, post-occupancy evaluation. Option D, strategic alignment loop. Take a moment to think about the goal of the action. Are we adding a brand new feature to the building, or are we correcting a mistake to bring it back in line with the original design? We will analyze the technical answer and the exam logic behind it on the next slide. The correct answer is Option B, negative feedback loop. This is a technical term that often confuses candidates. In the world of control theory and the PMI-CP exam, the word negative does not mean bad news or insulting. Instead, it refers to negating a deviation. Look at the logic flow on this slide. We have the plan or the specification, which is our desired state. Then we have the clash or the error, which is the deviation. The feedback and the resulting remediation plan are the correction used to close that gap. The objective is zero delta, meaning there is no difference between what was built and what was planned. It is a tool for compliance, not for emotional criticism. If you are fixing a defect to align it with the original spec, you are in a negative loop. If you were suggesting a way to improve the building's energy efficiency beyond the original spec, that would be a positive loop. Understanding this technical distinction is vital for answering governance questions accurately. Feedback should not be something that only happens during the construction phase. It must be a continuous process that spans the entire project lifecycle, from conception and design to construction and eventually operation. However, research identified a critical gap in our industry: the lack of feedback capture in the post-occupancy phase. We often complete a facility, hand over the keys, and never look back. This is a major failure of project governance. By failing to capture feedback during the operation phase, We never learn how the facility is actually used compared to how it was designed. Did the open plan office actually improve productivity? Did the HVAC system handle the real-world tenant load? Without post-occupancy feedback, we are doomed to repeat the same design mistakes on our next project. As a certified professional, your strategy should include mechanisms to bridge this critical gap, ensuring that lessons learned during operations are fed back into the conception phase of future projects. This turns a single project into a permanent learning organization. Not all feedback is created equal. In fact, research shows that a massive 1/3 of feedback interventions actually reduce performance. Why does this happen? Usually, it is because the feedback is too vague, focuses on personal traits rather than actions, or amounts to general praise or criticism. To be a successful manager, you must follow the exam rule. Effective feedback must be task-specific. Look at the comparison on the slide. An ineffective manager says, "Good job on the concrete pour." This is vague and provides no learning. An effective manager says, "The pour achieved the target slump because the mix timing was adjusted for the rising afternoon temperature." This provides a specific learning that the team can repeat in the future. It moves the focus away from the person and places it squarely on the technical task. When you are giving or receiving feedback, always look for the technical why. This is how you use communication to drive performance and continuous improvement on a job site. As we near the end of our lecture, let's identify the 4 most common traps that lead to project failure. First is a late start, developing your communication strategy after the RFP is issued. This results in a misaligned budget and mismatched expectations that are nearly impossible to fix later. Second is rigidity, ignoring stakeholder turnover. As we saw in our rail project scenario, if you don't adapt to new leadership, you will lose the support of your sponsors. Third is one-way traffic, the mistake of thinking that reporting is the same as exchanging. If you are only sending data out but not receiving feedback in, you are missing vital quality assurance opportunities. Finally, there is emotional interpretation. The error of confusing negative feedback with personal criticism. In the built environment, we must view negative feedback as a technical, gap-closing tool. If you take it personally, you will fail to identify and fix the technical gaps that lead to rework. Avoiding these 4 traps will make your communication governance far more resilient and successful. Let's review the 5 essential pillars of today's module. First, strategy precedes the plan. You must define the why, the strategy at the RFP stage, before you ever worry about the how, the plan. Second, flexibility is a form of governance. Your strategy must be a living document that evolves as stakeholders change over the project's 5-year or 10-year life. Third, remember that in technical terms, negative means gap closing. Use negative loops to fix defects and restore alignment with the specifications. Fourth, always insist on task specificity. Feedback must be specific to the technical task to be effective. Vague praise is a wasted opportunity. Finally, prioritize crisis readiness. Every management plan must include proactive protocols, designated spokespersons, and clear approval channels before the first crisis occurs. These 5 principles turn communication from an extra into a core project control. If you master these, you are well on your way to mastering Domain 1 of the PMI-CP exam. As we conclude, let's look at the foundational model that the entire exam is built upon. Success in communication is not just about delivering a message, it is about the entire circuit. We have the sender, the message, and the receiver. But in our industry, the circuit isn't complete until we have feedback and action. The exam will test whether you understand that your responsibility as a project manager doesn't end when you hit send on a report or an RFI. You are the governor of the entire loop. You are responsible for ensuring the message was not just delivered, but received, understood, and, most importantly, acted upon. If a message is sent but no action follows, the communication has failed, and the risk to the project remains. By taking ownership of the entire loop, you ensure that information translates into site progress and project success. Welcome to Lecture 5 of our PMI-CP exam preparation series. Today we are diving into a critical component of construction leadership, stakeholder management for communication. This session focuses on the triad of analysis, engagement, and resistance management. If you have spent any time in the built environment, you know that technical plans are only as strong as the people who support them. Our goal today is to learn how to effectively connect your project plan to the actual people who execute it every single day. In construction, we deal with rigid schedules and fixed blueprints, but stakeholders are fluid and dynamic. Understanding how to navigate their needs is what separates a technician from a true project leader. We aren't just looking at who these people are. We are looking at how their influence can either accelerate your project or bring it to a grinding halt. By the end of this module, you will have a clear framework for identifying who matters most and how to keep them aligned with your project goals. We will start with the technical tools of the trade, the matrices and grids that help us categorize our stakeholders. From there, we will move into the strategic territory of how to handle resistance. Construction is inherently disruptive, and change is often met with pushback. This lecture provides a structured way to manage that pushback proactively. Let's dive into our specific learning objectives to see exactly what you need to master for the exam. To ensure you are fully prepared for the PMI-CP exam, we have established 3 primary learning objectives. First, you must master the identify and assess phase. This involves learning how to correctly use power, interest, and engagement matrices to categorize every stakeholder on your list. This isn't just an administrative exercise. It's about knowing where to focus your limited energy and resources to maximize project stability. Our second objective is to strategize. We will apply a specific 6-step closed-loop process to establish communication plans that actually work. Communication should never be a one-way street, and this process ensures you are constantly gathering feedback and adjusting your approach. Third, we will learn how to overcome resistance. You need to be able to distinguish between prevention, proactive management, and reactive management of change resistance. Pay close attention to the exam focus on this slide. The exam is going to test your ability to select the correct matrix for a specific construction scenario and judge the best communication approach for a resistant stakeholder. It's about your situational judgment as much as your knowledge of the terms. Let's start by looking at the 2 fundamental reasons why we manage stakeholders in the first place. Why do we put so much effort into stakeholder management? It really comes down to 2 twin objectives. The first is improving team performance. When you manage your internal stakeholders well, you build trust, which naturally removes conflict. Furthermore, by establishing clear roles, you reduce the ambiguity that often leads to errors on a job site. A team that trusts its leadership and knows its role is a high-performing team. The second objective is overcoming resistance. Let's be realistic. Construction projects are inherently disruptive. We block traffic, we make noise, and we change neighborhoods. Effective management creates a cooperative environment that allows us to placate resistance before it reaches a level that stops the work. As Charles Kettering famously said, "The world hates change, yet it is the only thing that has brought progress." Getty Images explore. In our industry, we are the agents of that progress. Our job is to bridge the gap between the status quo and the improvement our projects represent. If we don't manage the human reaction to that change, we risk failure regardless of our engineering prowess. Now let's look at a real-world case study to see what happens when these objectives are ignored. To understand the stakes, we can look at the Signature Bridge project in New Delhi. This project suffered a major failure because it missed a critical deadline for approval from the Environment Clearance Board. When we look at the cause, it wasn't a technical error, it was a lack of a single point of ownership for that stakeholder relationship. The result was severe schedule delays and massive cost overruns. This case study highlights the common pain points you need to recognize for the exam. Conflict and distrust arise when roles are undefined. Scope creep occurs when messaging is vague, and stakeholders fill the gaps with their own expectations. And of course, delays are frequently caused by missed approvals or poor reporting structures. To prevent these issues, we follow a strict governance rule. Every stakeholder must have a single point of ownership within your project team to avoid any ambiguity. This person is the champion for that stakeholder's needs and the primary point of contact. This ensures that a critical board approval never slips through the cracks because someone else was supposed to handle it. Now, let's look at the specific tools we use to analyze these stakeholders. To be an effective analyst, you need the right tools in your toolkit. We rely on 3 specific matrices to categorize and track our stakeholders. The first is the power versus interest matrix. Its purpose is prioritization. It maps a stakeholder's ability to interrupt the project against their level of alignment or interest. This tells you exactly how much energy you need to spend on each person. The second tool is the stakeholder analysis matrix. Think of this as your deep dive tool. While the power interest grid gives you a snapshot, this matrix digs into the why. It helps you assess the political, financial, and even ethical motivations of your stakeholders. Understanding these drivers allows you to tailor your messaging to what actually moves them. The third tool is the engagement assessment matrix, also known as the CD matrix. Its purpose is tracking. It allows you to monitor a stakeholder's current level of support, C, versus where the project needs them to be, the desired level, D. By tracking this over time, you can see if your communication strategy is successfully moving the needle. Let's take a much closer look at that power interest grid. The power interest grid is the most common way to prioritize your time. You must understand these 4 quadrants for the exam. In the top right, we have manage closely. These are your high power, high interest key players. You must engage with them daily or weekly because they represent the greatest risk to your success if they feel sidelined. In the top left, we have keep satisfied. These stakeholders have high power but low interest. You must meet their specific needs, but be careful not to overwhelm them with day-to-day project drama. A classic example is a licensing board. In the bottom right is keep informed. These are your allies and eyes on the ground. They have high interest but low power, so you keep them in the loop to maintain their influence. Finally, in the bottom left is monitor. These are low power, low interest people. You check in on them periodically but do not spend excessive resources here. However, the grid is iterative. Never ignore them entirely, as their power or interest could shift as the project progresses. Now let's look at a specific quadrant that is a frequent trap for students. This is a critical exam insight for your preparation. Many candidates underestimate high-power, congé, low-interest stakeholders because they are quiet. These people don't care about your daily progress reports or your weekly newsletters. That's why they have low interest. However, they have the absolute authority to shut down your site in a heartbeat. Think of fire marshals, city inspectors, or licensing bodies. They aren't interested in your project schedule. They are only interested in whether you are following the rules. The exam logic is this: if a stakeholder is a gatekeeper but ignores your project meetings, then they belong in the keep satisfied quadrant. Your action for them is strict compliance. Do exactly what they require and do it on time. But, and this is key, do not flood them with trivial emails. They are busy and don't want the noise. They only want to know that the gate they guard is secure. Let's look at how this logic applies to a specific exam-style scenario. Let's walk through a typical exam scenario. You are building a high-rise, and the city chief fire inspector has the authority to stop all work if codes are violated. However, he rarely visits, missed your kickoff, and doesn't open your newsletters. You need his sign-off for the structural steel phase next month. How do you classify and treat him? The correct answer is C. High power, low interest, or keep satisfied. Let's look at why. He clearly has power because he can stop the work. But he has low interest because he ignores the daily details. If you tried to manage closely, you would likely annoy him with too much information he doesn't want. If you just monitored him, you would risk missing that critical sign-off. The keep satisfied approach means you ensure his specific code requirements are met and you reach out specifically for the sign-off without the daily noise. This is the strategic balance the exam is looking for. Now let's look at how we track engagement levels more broadly. Once we have categorized stakeholders by power and interest, we need to track their actual engagement level using the CD matrix. We use a scale of 5 levels. First, unaware, meaning they don't know the project's impact. Second, resistant, meaning they are aware but opposed. Third is neutral, where they have no opinion. Fourth is engaged, meaning supportive. And fifth is committed, meaning an active advocate. The matrix tracks where they are now, the current, C, versus where you need them to be, the desired, D. For a project sponsor, you likely want them at committed. For local residents who are currently resistant, your desired state might just be neutral. This is a critical insight. Your goal is not to make everyone a committed advocate. For resistant external parties, moving them from resistant to neutral, where they are no longer actively blocking your work, is a huge win and often an acceptable final goal. Stakeholder management is about pragmatism, not just popularity. To achieve this movement from C to D, we use a structured 6-step process. Effective stakeholder communication is a process, not a random act. We use this 6-step closed-loop process to move stakeholders toward our desired engagement level. It starts with step 1, summarize status, which is that C versus D assessment we just discussed. Step 2 is to decide requirements, identifying exactly what support you need from them. In step 3, you identify the key message, specifically focusing on the benefits for them. Step 4 is to identify the approach, which is your delivery method. Is it a meeting, an email, or a site tour? Step 5 is to implement the plan and actually send the message. Finally, step 6 is to gather feedback. This must be bidirectional. You aren't just checking that they received the message. You are listening for their reaction to see if their engagement level has actually moved. If it hasn't, the loop begins again. Let's look closer at step 3, as crafting the right message is often where project managers struggle. Step 3, identifying the key message, is another major exam focus point. Most project managers default to project-centric messaging. A bad message would be, "We are closing the road for 3 days." This message only tells the stakeholder about a disruption that benefits you, but creates a headache for them. To move a resistant stakeholder, you must transform that message to be stakeholder-centric. A good message would be, "We are upgrading utilities this weekend to prevent power outages during your business hours." Both messages describe the same road closure, but the second one aligns with a stakeholder benefit. The logic is simple. When crafting a message for a resistant stakeholder, do not just state what you are doing. Instead, state how it benefits them, or perhaps more importantly in construction, how it prevents a loss for them. People are much more likely to support a disruption if they understand why it's in their best interest to do so. This is the cornerstone of managing resistance, which we will explore now. Resistance to change is a natural response in any project environment. We can categorize sources of resistance into 2 groups. Internal resistance from your team or subs often comes from fear of the unknown, loss of status, or change fatigue. External resistance from the public or unions usually stems from disruption, environmental concerns, or labor agreements. We manage this resistance through three avenues. The first is prevention. This involves communicating the why and the risks of not changing before the change even occurs. If people understand that staying the same is more dangerous than changing, they are more likely to get on board. The second avenue is proactive management. This is about identifying sources of resistance early using tools like anticipating resistance workshops. Finally, we have reactive management. This is crisis management after something has gone wrong. This is the least desirable place to be, as you are now fighting an uphill battle. Let's look closer at that proactive workshop tool. The Anticipating Resistance Workshop is one of your most powerful proactive tools. It is a structured discussion held with targeted groups before you implement a controversial change. The objective is to identify where resistance will come from so you can design mitigation measures into your rollout plan. During these workshops, you want to create a unified value proposition. You are essentially aligning the change with the team's own values. You want them to see the personal or professional value in the new way of working. Here is an exam tip for your situational questions. If a question asks what you should do before rolling out a new system, look for answers like conduct a workshop or proactive engagement. Always avoid options that suggest you should simply mandate compliance. In the PMI world, forcing someone to do something is never as effective as educating them on why it's better for them. Let's see this in a final scenario. In this final scenario, your project is moving to a new digital daily reporting system. However, your older site foremen are refusing to use the tablets, claiming they slow down work, and they are reverting to paper logs. This is causing data gaps for the project. What is the best action? Option A is mandate tablet use. This is coercive and usually just creates more resistance. Option C is allow them to use paper. This is avoidance and doesn't solve your project's data problem. The correct action is B. Schedule a training workshop. Why? Because resistance often stems from knowledge and skill deficits. The foreman might simply be afraid they won't know how to use the tool. By scheduling a workshop, you address those skill deficits, and crucially, you sell the benefit by explaining how the system will save them time in the long run. This is the proactive, education-based approach the exam expects. Now, let's wrap up with our key takeaways. We have reached the end of Lecture 5. Let's recap the 4 key takeaways for your exam and your career. First, for identification, always use the power-interest matrix. Most importantly, do not ignore the keep satisfied quadrant, those high-power, low-interest stakeholders who can shut you down without warning. Second, for your strategy, follow the 6-step loop. Remember that effective communication must be bi-directional. If you aren't listening for feedback, you aren't communicating. You're just broadcasting. Third, when dealing with resistance, aim for prevention by explaining the why and use proactive tools like workshops to catch issues early. Avoid being reactive whenever possible. Finally, maintain agility. Stakeholder management is an iterative process. People change, their interests shift, and their power can grow or shrink as the project moves through different phases. You must update your CD assessments regularly to stay ahead of the curve. Thank you for your time today, and good luck with your continued study. Welcome to Lecture 6 of our PMI-CP exam preparation series. Have you ever walked away from a high-stakes site meeting feeling like everyone was in total agreement, only to discover 3 days later that a critical instruction was completely misinterpreted? This breakdown often happens because, in the rush of a project, we mistake hearing for listening. In the high-pressure world of the built environment, communication isn't just about social rapport, it is a core component of project governance. In this session, we are moving beyond the basic administrative tasks of sending emails and filing reports. We are going to explore active listening and cultural intelligence as literal technical tools. These are not just soft skills. When you are managing a multi-million-dollar infrastructure project, being able to decode the true meaning behind a stakeholder's words is just as critical to the project's health as reading a structural blueprint. Throughout this lecture, we will establish why these skills are considered technical project controls and how they directly impact rework, claims, and safety outcomes. We will look at how different cultural backgrounds influence how information is filtered and how decisions are made. Finally, we'll provide you with a structured methodology for active listening that ensures a message sent actually becomes a message received. Mastery of these concepts is essential for any project manager looking to mitigate risk and ensure true alignment among diverse stakeholders. Let's begin by looking at our specific learning objectives for this module. What does mastery look like when it comes to project communications? It starts with 4 key objectives designed to align your daily interactions with successful project outcomes. First, we need to analyze nuance. In a multi-party environment like a construction site, where owners, consultants, and subcontractors all have different priorities, there is often a massive gap between the message sent and the message received. Our goal is to provide you with the tools to bridge that gap. Second, we will learn to navigate culture. Every person on your team decodes information through a unique lens shaped by their experience, professional background, and cultural upbringing. Identifying how these backgrounds influence decision logic and information filtering is essential for keeping a global project on track. Third, we will apply governance. We are going to treat active listening as a literal risk mitigation tool. By listening for what is not said, you can prevent scope creep and identify safety hazards before they result in an incident. Finally, we will learn to evaluate intent. Sometimes, stakeholders agree simply to end a meeting or avoid conflict, but they have no intention of following through. This is known as passive resistance, and we will teach you how to detect it and resolve ambiguity to ensure true alignment. I want to emphasize the exam context here. The PMI-CP exam doesn't treat listening as a way to build social rapport. Instead, it tests listening as a mechanism for the verification and validation of requirements. Think of it as a quality control process for the information that drives your project. Why are we categorizing active listening as a technical skill? Because in the built environment, communication failures are not just annoying. They are a leading cause of rework and expensive insurance claims. If a laborer installs a rebar cage incorrectly because they misunderstood a technical instruction, that is a failure of project control. In this context, active listening is a project control mechanism designed to prevent rework and claims. Consider the concept of risk mitigation. Team members often say, "I got this," simply to avoid conflict or appear competent in front of a supervisor. Active listening allows a leader to uncover technical misunderstandings hidden behind those words. It is also essential for safety. A reluctance to raise risks often stems from a leader's failure to listen to the subtle cues of hesitation. As Peter Drucker famously stated, the most important thing in communication is hearing what isn't said. Finally, listening increases project velocity. By reducing the cycle time spent clarifying instructions or fixing mistakes, you move faster. If everyone understands the task perfectly the first time, you eliminate the communication gap that leads to errors. For the PMI-CP exam, you must view every conversation as a data collection exercise. If you aren't listening actively, you are missing out on the primary data points that could prevent the next major project failure. Active listening is the technical shield that protects your project's quality and safety. To improve our listening, we have to understand the technical mechanics of how a message travels. This process is never a perfect one-to-one transfer of data. It starts with the sender. The sender encodes a message based on their specific technical background. professional jargon, and subjective biases. An architect and a plumber might use the same word, but encode it with two different technical meanings. Next is the message and the channel. This is the medium you choose, whether it's a formal RFI, an email, or a face-to-face site meeting. Every channel has noise. In our industry, noise isn't just a loud sight. It's also distorted facts, poorly written text, or environmental distractions that make the message harder to decode accurately. Finally, we have the receiver who decodes the message. But here is the critical part. The receiver always decodes that message through their own lens. This lens is constructed from their cultural background, their personal biases, and their past project experience. This means that information is never truly objective. Every time you speak or listen, you are working through these filters. As a project manager, your job is to account for this lens, to ensure the message that was encoded is accurately decoded. If you ignore the lens, you're inviting a communication gap that can lead to structural or financial errors. On global projects, you will encounter two very different communication styles: high context and low context. Understanding these is a vital part of your cultural intelligence. High context communication is heavily reliant on nonverbal cues, tone, and the overall context. In these cultures, common in many parts of Asia, the Middle East, and Latin America, silence or hesitation often implies disagreement or a polite no. For example, if a foreman says, "The concrete seems different than usual," they might actually be telling you to stop the pour immediately because they suspect a batch error. In contrast, low-context communication, prevalent in North America and much of Europe, relies on explicit verbal accuracy. Directness is highly valued here. If the instruction is not stated clearly, it is assumed not to exist. An example would be a project manager stating, "The slump is 5 mm off spec." This is an explicit, data-driven instruction where the meaning is entirely contained in the words themselves. As a project manager, you must calibrate your listening style to the specific cultural coding of your stakeholder. You cannot listen to everyone the same way. You must realize that a yes is not always a confirmation of execution. It might just be a polite way of acknowledging your authority. By decoding the lens, you can identify the risks that a low-context manager might miss entirely. This calibration is what ensures that your technical instructions are carried out exactly as intended across a diverse workforce. Active listening is not a passive activity. It is a structured methodology that we break into two phases. Phase 1 is all about preparing the environment to ensure that an actual transfer of knowledge can occur. There are 3 initial steps in this phase that every project manager should follow before discussing technical requirements. Step 1. Create time for listening. We are all busy, but half listening while rushing to a site walk is dangerous. If you cannot listen now, do not fake it. Instead, schedule a dedicated time. This signals that the stakeholders' input is valuable enough to warrant your full focus. Step 2. Listen with intention to understand. Your goal here is to listen to understand the other person's perspective, not just to formulate your own response. You are trying to clarify the true intent behind their words. Are they raising a concern because they are worried about the schedule, or are they worried about safety? Step 3. Avoid interruptions. In our digital world, this requires digital silence. Multitasking, like checking your phone or looking at your watch while a subcontractor is speaking, destroys your cognitive focus and, more importantly, destroys the trust you are trying to build. By creating this safe environment for communication, you are setting the stage for accurately processing the technical data you are about to receive. Without Phase 1, the data you receive in Phase 2 will likely be incomplete or distorted. Phase 2 of the active listening methodology moves from preparation to processing and validating the information. This is where the technical alignment between the sender and receiver happens. Step 4. Process what you've heard and avoid judgment. As a project manager, you must record facts neutrally in your mind or notes. Avoid the common bias of immediately formulating a contractual defense or a rebuttal while the other person is still talking. If you are already thinking about how to cite a delay clause, you aren't processing the technical reason for that delay. Your job at this stage is objective data collection. Step 5. Repeat for validation, or what we call loop closing. This is the most critical step for technical professionals. You must paraphrase the technical content back to the sender to ensure you've got it right. For example, you might say, "So, you are saying the steel delivery delay impacts the critical path unless we resequence area B. Is that correct?" When the other person confirms, you have officially closed the loop. This transfers the ownership of the understanding to both parties. You are now technically on the same page, and this validation serves as your verification that the requirements are understood. Let's analyze an exam-style scenario involving cultural context in risk identification. You ask a senior engineer from a high-context culture if a foundation design is viable. Instead of giving a direct technical answer, he looks down, remains silent for a moment, and then nods slightly. You ask, "Are we good?" And he nods again. You take this as agreement, move forward, and later, a major design flaw is discovered. What went wrong in your decision logic? The correct action you should have taken was to privately approach the engineer after the meeting to ask open-ended questions. Accepting the nod as confirmation is a mistake. Why? Because in many high-context cultures, public disagreement or saying no directly to a manager causes a catastrophic loss of face. He felt he could not contradict you in front of the group. His silence and lack of eye contact were actually nonverbal risk data. He was telling you there was a problem, but he couldn't do it publicly. By taking the conversation private, you respect the cultural norms while extracting the technical truth you need to protect the project. Publicly challenging him would have only made him shut down further. This scenario teaches us that an active listener must be a cultural decoder, looking for the risks hidden in the silences. When a stakeholder brings you information, how do you respond? We can categorize your responses into a hierarchy of 3 levels. Understanding these levels is vital for your exam performance and site leadership. Level 1 is disagree and defend. This is the lowest level and the most common trap for new or stressed managers. You interrupt the sender to cite contract clauses or defend your position. The outcome is always negative. You miss out on critical information because the sender stops talking, and you damage the trust with your team. Level 2 is jump to a solution. You offer a fix before you have the full context. While this feels efficient, the outcome is often a band-aid solution that leads to future rework because you didn't address the underlying root cause. Level 3 is our goal. Listen with intention. This is where you allow the stakeholder to give a full explanation of their constraints without interruption. The outcome here is a shared understanding and ultimately a root cause resolution to the problem. In the built environment, where technical issues are often complex, jumping to a solution, level 2, is a massive risk. Always strive for level 3 to ensure you are solving the right problem the first time. Taking the time to listen fully is actually the fastest way to solve a technical issue. This is a major exam focus point regarding the tension between efficiency and effectiveness. The exam will try to trap you by presenting a scenario under extreme time pressure. For example, a major concrete pour is starting in an hour, or a massive bid is due in 60 minutes. In that moment, a stakeholder raises a vague concern. Your human instinct is to be efficient, to jump to a solution, just to keep the project moving and meet the deadline. However, the exam logic of the PMI-CP is very different. It prioritizes risk management over immediate speed every single time. The correct approach in these high-pressure scenarios is to pause. Invest just 5 minutes to listen actively to that concern. The loss of those 5 minutes is preferred over the massive risk of a safety incident or a quality defect that could have been avoided. If you solve the wrong problem quickly, you haven't been efficient, you've been reckless. On the exam, always choose the path that validates the concern before moving to the technical execution. The most effective project manager is the one who ensures they are moving in the right direction, even if it takes a moment to confirm the path. Sometimes, a stakeholder's yes actually means no. This is what we call passive resistance, and specifically, the non-compliant agreeable. By definition, this is a stakeholder who appears to agree with your direction, but has absolutely no intention of taking action once the meeting ends. As an active listener, you must be able to spot the indicators of this behavior. Look for vague commitments, such as, "We'll try to get to it." Watch for body language that contradicts their verbal agreement, like crossing their arms or looking away while saying, "Okay." Another major red flag is a total lack of follow-up questions on a complex technical task. If you give a difficult instruction and they just nod without asking for details, they probably aren't planning to do it. Your governance strategy has 2 options. First, probe deeply. Ask very specific questions about resources and timelines to test the reality of their commitment. If they can't tell you how they will do it, they won't. Second, if the resistance persists, utilize formal escalation through your stakeholder engagement processes. Don't try to force compliance by yourself. Use the established governance structure to resolve the roadblock. Passive resistance is a silent project killer. Active listening is the only way to detect it. Let's look at a scenario involving a reluctant subcontractor to see how we validate commitments. A subcontractor is behind schedule. You emphasize the critical deadline, and the foreman crosses his arms, looks away, and says, "Sure, we will try to double the crew next week." How do you handle this response? If you just record that commitment in your meeting minutes, you are ignoring the clear signs of passive resistance. You are essentially inviting another week of delay. If you aggressively remind him of liquidated damages, you are damaging the trust, and he still might not follow through. The correct decision logic is to ask him to detail exactly where that new crew is coming from and what their specific tasks will be. You are forcing the stakeholder to operationalize their vague promise. This reveals immediately if the commitment is real. If the foreman can't provide these details, you know the promise was just a way to end the conversation. Active listening here is your tool for uncovering the truth before another week of delay occurs. Citing the contract might be your next step, but your first step must be to reveal the reality of the situation through probing questions. In complex group settings, like a major design review or a bidding meeting, it is impossible for one person to catch every technical detail while also facilitating the conversation. To maintain communication governance, you must add structure to the meeting by assigning listening roles. The first role is the clarifier. Their job is to listen specifically for complexity and jargon. Whenever someone uses a vague technical term or a complex explanation, the clarifier steps in and asks, "What did you mean by that?" This forces the speaker to rephrase their point in simple, unambiguous terms that everyone in the room can understand. This prevents silent misunderstandings. The second role is the challenger, or the devil's advocate. Their job is to test the assumptions and the validity of any technical claims being made. This is absolutely crucial in bidding, where you need to verify that a contractor's proposed method is actually viable and not just a miracle solution to win the work. Here is an exam tip. If you get a scenario describing a chaotic meeting where no one is on the same page, the answer is often to structure the communication by assigning these roles. It's not about just paying more attention. It's about a formal governance structure for the conversation. As a project manager, you have to match your communication style to the ambiguity tolerance of your team members. Not everyone processes instructions the same way. Identifying these traits through active listening is a key part of team management. Some people have a low tolerance for ambiguity. They need precise, discrete tasks to feel secure and perform well. They often get frustrated by outcome-driven requests like, just make the site ready. If you are working with this type of person, your action is to break down complex workflows into clear steps before you assign them. This ensures they can execute the task without the stress of the unknown. Other people have a high tolerance. They are comfortable with undefined methods and are actually motivated by solve-the-problem requests. For them, your action is to assign the goal, not the steps. If you micromanage a person with high ambiguity tolerance, you will demotivate them. The exam application here is clear. There is no one-size-fits-all communication style. You must listen to your team and match the clarity of the task to their specific personality. This is how you optimize performance across a diverse team of engineers, trades, and specialists. Let's look at a scenario involving an urgent change request and how to avoid what we call the solution trap. A client calls you in a panic, demanding that you immediately change the lobby flooring because it looks cheap. The catch? All the materials are already ordered and paid for. What should you do first? If you immediately explain that the materials are ordered, you are in disagree and defend mode, which will only escalate the client's panic and damage the relationship. If you halt the order immediately, you have jumped to a solution that might create massive financial waste if the change isn't actually necessary. The correct decision logic is to ask the stakeholder to explain specifically what aspect of the flooring concerns them. You must listen with intention. You might discover that the cheap look they are worried about isn't the material itself, but perhaps the finish, or even just the lighting in the room. By listening for the root cause before you act, you can find a solution, like a different light fixture, that satisfies the client without the technical and financial cost of stopping the order. Always verify the why before you touch the project schedule or budget. We have covered the foundational principles of active listening and cultural intelligence, so let's summarize the 5 key takeaways you need for the exam. First, always remember that communication is subjective. You must account for the lens, the culture and experience of both the sender and the receiver in every interaction. Never assume a message is received exactly as you sent it. Second, active listening is a formal process, not just a feeling. It requires you to create dedicated time, remove distractions, and most importantly, validate that you understood the message correctly by paraphrasing it back. Third, avoid the response traps. Do not disagree and defend or jump to solutions before you have all the data. Fourth, be vigilant in managing resistance. You must probe vague agreements to uncover the passive resistance that leads to project delays. Finally, view communication through the lens of risk management. Your goal is to understand the root cause of any issue via listening before you take any technical or contractual action. If you master these principles, you will be able to analyze situational questions correctly and select the best PM action on the exam. These are the core concepts that separate a successful PMI-CP candidate from the rest. Congratulations! You have completed Lecture 6 on active listening and cultural intelligence. You now have a set of technical tools to manage the human lens that filters every project communication. Before you move on, I want you to take 3 specific next steps to solidify this learning. Step 1. Go back and review the definition of passive resistance. Being able to identify the non-compliant agreeable is one of your most valuable skills as a project manager on a real job site. Step 2. Complete the practice quiz regarding high context versus low context communication. This will ensure you can correctly identify cultural risks on the exam. Finally, once you feel confident in these areas, proceed to Lecture 7. Thank you for your hard work and your commitment to becoming a certified construction professional. The skills we discussed today will not only help you on the exam, but will also improve your effectiveness on every project site you lead. Good luck with your study, and I'll see you in the next lecture. Welcome to Lecture 7 of our PMI-CP exam preparation series. Have you ever felt like you were in the middle of a high-stakes construction project where nobody knew who had the final say on a change order or where teams were working in complete silos? This is the chaos that occurs when a project lacks a clear framework for authority and collaboration. Today, we are focusing on the structural backbone of project delivery: governance, collaboration, and systems. We are moving beyond the soft skills of communication into the hard structures of governance. We will explore how to establish clear lines of authority, how to use the big room or obeya concept to drive real-time problem solving, and how to implement commitment-based management to replace vague best efforts with reliable promises. Finally, we will look at the digital systems, specifically PMIS and Compass, that serve as the single source of truth for your project. To ensure you are fully prepared for the PMI-CP exam, we have aligned this lecture with 4 critical objectives. First, we will focus on structure. You must be able to define project governance and clearly distinguish between the strategic oversight provided by a project board and the delegated authority given to you as a project manager. Understanding where your power begins and ends is a major theme on the exam. Second, we will look at space. We will explore how to apply the obeya, or big room concept. This is about more than just a physical meeting space. It's a shift from traditional command and control management to manage by exception. You will learn how to set up an environment where the team handles the normal flow, and you only intervene when project parameters are breached. Third, we will address behavior through commitment-based management, or CBM. In complex construction projects, accountability often gets lost in the matrix. CBM replaces the traditional hierarchy with a network of reliable promises, effectively eliminating silos. Finally, we will look at systems. You need to know the difference between a PMIS, which controls project performance and data, and Compass, which is a diagnostic tool used to measure the health of your project's communication flow. Let's dive into the core definition of governance. Welcome to Lecture 7 of our PMI-CP exam preparation series. Have you ever felt like you were in the middle of a high-stakes construction project where nobody knew who had the final say on a change order, or where teams were working in complete silos? This is the chaos that occurs when a project lacks a clear framework for authority and collaboration. Today, we are focusing on the structural backbone of project delivery: governance, collaboration, and systems. We are moving beyond the soft skills of communication into the hard structures of governance. We will explore how to establish clear lines of authority, how to use the big room or obeya concept to drive real-time problem solving, and how to implement commitment-based management to replace vague best efforts with reliable promises. Finally, we will look at the digital systems, specifically PMIS and Compass, that serve as the single source of truth for your project. This lecture is designed to give you the structural tools to lead large-scale, complex projects in the built environment. Whether you are navigating a matrix organization or managing a massive joint venture, understanding these frameworks is essential for your success on the exam and in the field. Let's start by looking at our specific learning objectives for this session. To ensure you are fully prepared for the PMI-CP exam, we have aligned this lecture with 4 critical objectives. First, we will focus on structure. You must be able to define project governance and clearly distinguish between the strategic oversight provided by a project board and the delegated authority given to you as a project manager. Understanding where your power begins and ends is a major theme on the exam. Second, we will look at space. We will explore how to apply the obeya, or big room, concept. This is about more than just a physical meeting space. It's a shift from traditional command and control management to manage by exception. You will learn how to set up an environment where the team handles the normal flow, and you only intervene when project parameters are breached. we've covered the entire journey from framework to execution today. To summarize, governance is your project's constitution. It defines the rules and the authority levels. Commitment-based management is the behavior we need from our people, turning vague intentions into reliable promises. Obeya is the physical or virtual space that enables manage by exception and visual problem solving. And our systems, PMIS and Compass, are the tools we use to control the data and diagnose the communication health. Here is your final exam tip. When you read a situational question, first identify the root of the problem. Is it a question of authority? If so, the answer is in governance. Is it a question of collaboration or silos? If so, look for Obeya or CBM. Is it a question of data accuracy? Look to the PMIS. Mastering these distinctions is the key to passing the PMI-CP and, more importantly, to bringing order to the complex world of the built environment. Good luck with your studies, and I will see you in the next session. To ensure you are fully prepared for the PMI-CP exam, we have aligned this lecture with 4 critical objectives. First, we will focus on structure. You must be able to define project governance and clearly distinguish between the strategic oversight provided by a project board and the delegated authority given to you as a project manager. Understanding where your power begins and ends is a major theme on the exam. Second, we will look at space. We will explore how to apply the Obeya or big room concept. This is about more than just a physical meeting space. It's a shift from traditional command and control management to manage by exception. You will learn how to set up an environment where the team handles the normal flow, and you only intervene when project parameters are breached. Third, we will address behavior through commitment-based management, or CBM. In complex construction projects, accountability often gets lost in the matrix. CBM replaces the traditional hierarchy with a network of reliable promises, effectively eliminating silos. Finally, we will look at systems. You need to know the difference between a PMIS, which controls project performance and data, and Compass, which is a diagnostic tool used to measure the health of your project's communication flow. Let's dive into the core definition of governance. What do we actually mean when we say project governance? As O.E. Williamson famously noted, governance is the effort to craft order. In the built environment, it is the framework that connects our project objectives to the resources and processes we use to achieve them. It is the constitution of the project. The stakes here are incredibly high. Research from the Construction Industry Institute shows that only 5.4% of industrial projects meet best-in-class predictability without strong governance. This means that without a clear structure, you are almost guaranteed to fail on your budget or schedule. Governance provides the rules of engagement that mitigate conflict and ensure that all stakeholders can realize mutual gains. There is a fundamental distinction you must understand for the exam. Governance is not management. Management is the act of running the project, directing the crews, ordering materials, and updating the schedule. Governance is the structure within which that management operates. It defines who is allowed to make which decisions. Think of it this way. Management is the driver of the car, but governance is the road, the traffic lights, and the rules of the road. Let's look at how this structure is built through hierarchy. In a well-governed project, there is a clear hierarchy of authority. At the top, we have the project board or steering committee. These are the stakeholders who set the desired outcomes and hold the ultimate decision-making authority. They are not there to manage the day-to-day work. They are there to provide strategic oversight and resolve high-level conflicts that the project manager cannot. Below the board is the project manager. The most important concept here is that the PM is the single point of accountability. This means that while you may delegate tasks, you cannot delegate the ultimate responsibility for the project's performance. However, you operate within delegated authority. You have the power to make decisions up to a certain point, whether that's a dollar amount or a schedule deviation, but once that threshold is crossed, you must go back to the board. This structure relies on three principles: single point of accountability, defined roles, and efficient decision-making through manage by exception. Below the PM, we have expert groups, like structural engineers or legal counsel, and the delivery teams on the ground. This clear chain of command ensures that communication flows from one source and that decisions are made at the right level, preventing the bottlenecks that occur when a PM tries to do everything themselves. Let's look at an exam scenario involving these authority thresholds. Let's look at a scenario you are likely to encounter on the PMI-CP exam. You are the project manager for a high-rise development. An electrical contractor discovers a design error and requests a scope change that will increase their cost by 4%. The contractor is demanding an immediate answer to avoid holding up the schedule. You check your budget and see that you have plenty of project contingency to cover this, but the specific dollar amount is just above your delegated financial authority. What is the best action? The trap here is to select option 1, approving it immediately to save the schedule. However, in the world of governance, following the rules is more important than immediate speed. The correct action is option 3, assess the impact and escalate the decision to the project board. Even if the funds exist, as a PM, you literally do not have the legal or structural power to approve that spend if it exceeds your limit. Rejecting it outright, option 2, is too aggressive and ignores the design error while asking for a cost reduction. Option 4 doesn't solve the authority issue. Governance means you prepare the data, explain the necessity, and ask the authorized body for the green light. Now, let's look at where these coordination efforts should actually happen: the OBEA. Traditional construction meetings are often where information goes to die. They are usually focused on status reporting, telling people what already happened, and they often encourage teams to hide bad news to avoid looking bad. This leads to siloed discussions, where the electrical team doesn't know what the plumbing team is doing. We solve this using the OBEA, or the big room. OBEA is a Japanese term meaning large room. It is a dedicated physical or virtual space where all key stakeholders gather. The goal is to move from command and control, where the PM dictates everything, to manage by exception. In an OBEA, the team handles the normal daily flow of work. Leadership only steps in when a parameter is breached. For example, if a delivery is late or a safety incident occurs. The OBEA is built on 3 pillars. First, visual management. We use live data, charts, and schedules on the walls so everyone can see the project's health at a glance. Second, problem solving. We don't come to the big room to read reports. We come to solve the problems identified by the visual boards. Third, cross-functional collaboration. By having the owner, the designers, and the contractors in the same room, we break down organizational barriers. It's about meeting today's project requirements today, not waiting for next week's meeting. To make an OBEA effective, we follow 6 core principles. First, everyone in the room must be aligned on the purpose. We aren't just here to build a building. We are here to meet specific project outcomes. Second, we use clear visual elements. If a stakeholder can't understand the status of a task within 30 seconds of looking at a board, the visual is too complex. Third, we advance work together. The OBEA is a work zone, not a gallery. We use it to coordinate handoffs in real time. Fourth, we engage the leadership. The PM and the board members should be present to make those exceptional decisions immediately. Fifth, we use systematic problem-solving methods like PDCA, plan, do, check, act, and A3 thinking. This ensures we aren't just talking about problems, but resolving them scientifically. Finally, we hold regular meetings to maintain the rhythm of the project. Here is an exam keyword alert. If you see a question that describes silos between teams, delayed decision-making, or conflicting versions of the schedule, the answer is almost always to implement an Obeya or a big room environment. It is the primary tool for real-time collaboration. But to make this room work, we need a specific behavior from our people, which brings us to commitment-based management. One of the biggest causes of delay in the built environment is the phrase, "I'll try to get that to you." In project management, trying is not a plan. Commitment-based management, or CBM, is a behavioral framework designed to replace best efforts with reliable promises. It views every deliverable as a formal promise between two people, regardless of their rank in the hierarchy. The CBM cycle has 5 clear steps. It starts with a request, someone clearly asking for a deliverable. Next is negotiation. The person receiving the request has the right to say no, or not by that date, until they can agree on a realistic timeline. Once they agree, it becomes a commitment or a promise. The next steps are delivery of the work and, crucially, a declaration of completion. The loop isn't closed until the requester accepts that the promise was fulfilled. This framework drives active responsibility. You aren't doing a task because your boss told you to. You are doing it because you made a personal promise to a teammate. This is especially powerful in matrix organizations, where people often have multiple bosses and obscure accountability. CBM makes it clear exactly who owes what to whom. It shifts the culture from passing the buck to owning the outcome. Let's see how CBM resolves a typical matrix conflict. Imagine you are managing a complex rail project. You have a specialist engineer assigned to your team, but they functionally report to an engineering director at the home office. You have a critical design package due, but the engineer stops working on it because their director asked them for a corporate status report. Now you have a bottleneck. What is the best approach? Option 1, complaining to the director, often makes the conflict worse. Option 2, updating the schedule, just accepts the delay without fixing the cause. Option 4, micromanaging, is a waste of your time. The correct PMI-CP answer is Option 3, implement commitment-based management. The root cause of this conflict is obscure accountability. The engineer feels their primary loyalty is to their functional boss, not your project deliverables. By using CBM, the engineer makes a reliable promise directly to you for that design package. This shifts their loyalty from the hierarchy to the project commitment. In a matrix environment, CBM is the tool that ensures the project remains the priority. Now, let's look at the digital systems that support this behavior. To maintain governance and collaboration, you need a single source of truth. This is your Project Management Information System, or PMIS. A PMIS is not just a piece of software like Procore or Primavera. It is the combination of software applications plus defined processes. If you have the best software in the world but no process for how to use it, you do not have a PMIS. A robust PMIS integrates all the key features of a project. It handles your schedule and planning, resource management, and budget. It provides control and performance data, so you can see if you are on track. It also serves as the repository for all project documents and data, from RFIs to blueprints. Imagine you are managing a complex rail project. You have a specialist engineer assigned to your team, but they functionally report to an engineering director at the home office. You have a critical design package due, but the engineer stops working on it because their director asked them for a corporate status report. Now, you have a bottleneck. What is the best approach? Option 1, complaining to the director, often makes the conflict worse. Option 2, updating the schedule, just accepts the delay without fixing the cause. Option 4, micromanaging, is a waste of your time. The correct PMI-CP answer is option 3, implement commitment-based management. The root cause of this conflict is obscure accountability. The engineer feels their primary loyalty is to their functional boss, not your project deliverables. By using CBM, the engineer makes a reliable promise directly to you for that design package. This shifts their loyalty from the hierarchy to the project commitment. In a matrix environment, CBM is the tool that ensures the project remains the priority. Now, let's look at the digital systems that support this behavior. To maintain governance and collaboration, you need a single source of truth. This is your Project Management Information System, or PMIS. A PMIS is not just a piece of software like Procore or Primavera. It is the combination of software applications plus defined processes. If you have the best software in the world but no process for how to use it, you do not have a PMIS. A robust PMIS integrates all the key features of a project. It handles your schedule and planning, resource management, and budget. It provides control and performance data so you can see if you are on track. It also serves as the repository for all project documents and data, from RFIs to blueprints. For the exam, remember these 3 requirements for PMIS data. It must be retrievable, searchable, and analyzable. If you can't find a document from 3 months ago in under a minute, your PMIS is failing. The PMIS ensures that everyone is working from the same version of the truth, preventing the unclear data and version control issues that lead to rework. While the PMIS manages the data, we have another tool to manage the people, the compass. If a project is struggling, how do you know if the problem is a technical error or a communication breakdown? We use a diagnostic tool called Compass, developed by the Construction Industry Institute. While the PMIS tells you what the performance is, Compass tells you why the communication might be failing. Compass measures 6 critical dimensions of communication health. First, accuracy. Is the info correct? Second, understanding. Do people actually know what the info means? Third, timeliness. Is info getting to people when they need it? It also identifies barriers to flow, ensures completeness of information, and verifies that procedures are being followed. You should use Compass as a baseline as soon as the project team is assembled. Then you use it periodically to diagnose the flow of information between the 3 main pillars: engineering, construction, and management. For example, if the construction team says they are waiting on drawings but engineering says they sent them, Compass will help you identify if the issue is timeliness, a procedure error, or a barrier in the PMIS. Let's look at a scenario where Compass is the hero. Here's a very common site scenario. Your project is 40% complete. The construction superintendent is furious, claiming that engineering drawings are always late and missing critical details, leading to work stoppages. The engineering manager is equally frustrated, providing logs that show every drawing was issued on or before the due date. The tension is high and work is stopping. What do you do? Options 1 and 4, forcing people to the site or reporting them to the board, are reactive and don't solve the underlying issue. Option 3, changing software, is expensive and might not be the problem. The correct action is option 2. Conduct a Compass assessment. The exam logic is always diagnose before acting. You have a classic discrepancy in perception. Compass is designed to measure timeliness and completeness objectively. By running the assessment, you might find that while engineering is on time, the procedures for how construction accesses those drawings are broken. Compass gives you the data you need to fix the root cause, not just the symptoms. Now let's look at some patterns to help you on the exam. To help you move quickly through the PMI-CP exam, I want you to look for specific keywords and patterns. The exam is designed to see if you can match the right tool to the right problem. If the problem involves silos or a lack of coordination between different departments, the answer will likely involve OBEA or visual management. If the question describes ambiguity in roles or gray areas in decision-making, you need to look for governance framework solutions. Here is a very common site scenario. Your project is 40% complete. The construction superintendent is furious, claiming that engineering drawings are always late and missing critical details, leading to work stoppages. The engineering manager is equally frustrated, providing logs that show every drawing was issued on or before the due date. The tension is high, and work is stopping. What do you do? Options 1 and 4, forcing people to the site or reporting them to the board, are reactive and don't solve the underlying issue. Option 3, changing software, is expensive and might not be the problem. The correct action is Option 2, conduct a compass assessment. The exam logic is always diagnose before acting. You have a classic discrepancy in perception. Compass is designed to measure timeliness and completeness objectively. By running the assessment, you might find that while engineering is on time, the procedures for how construction accesses those drawings are broken. Compass gives you the data you need to fix the root cause, not just the symptoms. Now let's look at some patterns to help you on the exam. To help you move quickly through the PMI-CP exam, I want you to look for specific keywords and patterns. The exam is designed to see if you can match the right tool to the right problem. If the problem involves silos or a lack of coordination between different departments, the answer will likely involve OBEA or visual management. If the question describes ambiguity in roles or gray areas in decision-making, you need to look for governance framework solutions. When you see matrix confusion or a lack of ownership, your mind should go straight to commitment-based management. For issues like unclear data or version control, the answer is almost always a PMIS solution. Finally, if there is friction or a he said, she said situation between teams regarding information flow, the answer is to use Compass for an objective diagnosis. Memorizing these pairings will significantly increase your speed and accuracy on the test. Let's look at some common mistakes to avoid. Let's clear up some common misconceptions that could cost you points. First is the dictator PM. Many people think the project manager has unlimited power over the project. This is false. In a governed environment, you operate with delegated authority. For major changes in scope or cost, you must go to the governance board. Don't fall for exam options where the PM makes a unilateral decision that exceeds their authority. Second is the OBEA as a showroom. Some projects build a beautiful big room just to impress clients or visitors. This is a mistake. An effective OBEA should look messy. It should be filled with live data, sticky notes, and marked up drawings. It is a work zone for real-time problem solving, not a gallery for guests. If the data on the walls isn't being used to make decisions today, it's not an OBEA. Finally, don't use Compass as a performance review. Compass is a diagnostic tool for the system, not the people. If you use Compass results to punish a specific engineer or contractor, people will stop being honest in the assessment. The goal is to fix the flow of information, not to judge someone's technical competence. Keep these corrections in mind as we wrap up. We've covered the entire journey from framework to execution today. To summarize, governance is your project's constitution. It defines the rules and the authority levels. Commitment-based management is the behavior we need from our people, turning vague intentions into reliable promises. OBEA is the physical or virtual space that enables manage by exception and visual problem solving. And our systems, PMIS and Compass, are the tools we use to control the data and diagnose the communication health. Here is your final exam tip. When you read a situational question, first identify the root of the problem. Is it a question of authority? If so, the answer is in governance. Is it a question of collaboration or silos? If so, look for OBEA or CBM. Is it a question of data accuracy? Look to the PMIS. Mastering these distinctions is the key to passing the PMI-CP and, more importantly, to bringing order to the complex world of the built environment. Good luck with your studies, and I will see you in the next session. Ever been on a project that's pulling in 10 directions? Teams confused? Stakeholders sidelined? The problem is often communication, not technical skill. In this session on building effective frameworks for complex projects, PMI-CP, we'll clarify a key difference: communication strategy versus communication plan. The strategy defines the why and what. The plan defines the who, how, and when. For complex infrastructure, IT, or major change projects, mastering both is essential. What if I told you that almost every major project has technically failed in some way? That's alarming when you consider the world spends roughly $9 trillion a year on projects, about 8% of global GDP. With that much at stake, you'd expect minimal error, but reality says otherwise. Global research shows that over 99% of megaprojects worth 1B+ miss their original budget, schedule, or promised benefits. High-speed rail, megadams, most don't hit their targets. The key point: many of these failures are preventable. One major driver is communication. Studies suggest 33% of project failures stem from ineffective communication, meaning trillions are lost because the right people didn't get the right information at the right time. This isn't about fewer emails, it's about how intent, decisions, and progress are communicated. As project leaders, we're stewards of this investment. To reduce failure risk, we start by defining our terms, beginning with the difference between the high-level blueprint and the tactical map. Imagine trying to build a skyscraper with only a local street map, or trying to navigate a new city with nothing but a floor plan of a single office building. You would fail in both scenarios because you're using the wrong tool for the task. In project management, we use the strategy as our blueprint and the plan as our map. Let's start with the communication strategy. This is your high-level architectural drawing. It documents the broad interventions and the core key messages you want to land. Its primary job is to ensure everyone is aligned on the what and the why. Why are we doing this project? What is the impact? It covers alignment from the bottom up, getting feedback from the field, and top-down, ensuring executive vision is clear. It is the strategy that keeps the project's soul and purpose intact. Next, we have the communication plan. If the strategy is the blueprint, the plan is the map that shows the actual path you'll walk every day. It moves away from the why and focuses heavily on the how and when. A robust plan details specific components. Exactly what message is being sent, which audience is receiving it, what media or channel is being used, and what specific activities are required. Crucially, it includes a timeline and assigns clear responsibilities. Who is hitting send and when? Now, this distinction might feel theoretical, so let's apply it to a real-world scenario where the stakes were incredibly high. We'll look at a major infrastructure project in South Africa that faced significant public and economic risks. What happens when a project threatens to shut down the very heart of a city's economy? In Polokwane, South Africa, the Integrated Rapid Public Transport System, or IRPTS, faced exactly this challenge. The project was essential for modernizing the city, but it brought massive road gridlock and significant traffic disruptions. Local businesses were terrified that customers wouldn't be able to reach them, creating a high-risk environment for the project's reputation and its physical progress. To survive, the project team couldn't just hope people would understand. They had to deploy a specific crisis communication plan. This wasn't just a generic update. It was a proactive risk management tool that focused intensely on traffic updates and public safety. They identified specific target audiences, from commuters to shop owners, and established protocols for prevention, immediate response to issues, and recovery after major disruptions. By treating communication as a tactical necessity rather than an afterthought, they achieved a remarkable outcome. They didn't just solve the gridlock, They maintained successful stakeholder engagement throughout the most difficult phases of construction. The public felt informed and respected, which reduced the friction that often kills major infrastructure projects. This case study proves that communication isn't just a soft skill, it is a hard asset that delivers tangible results. Now that we've seen a plan in action, let's categorize the specific benefits that a good strategy and a good plan bring to your team. Why do we bother with all this documentation? It's simple, because it creates a protective environment for your project. Let's look at how the strategy and the plan provide different layers of protection. First, the strategy provides high-level clarity. When you have a solid communication strategy, every single person on the team knows what is expected of them and what they are contributing to the bigger picture. It facilitates a two-way flow, meaning feedback isn't just coming from the top down. It's moving from the ground up and laterally between departments. This provides essential oversight. You gain visibility into what other teams are doing, their timelines, and their scope, which prevents silos from forming. Next, let's look at the plan. The plan is where the rubber meets the road. It supports your stakeholder engagement models by ensuring you aren't just talking at people, but engaging with them based on their specific needs. It defines the information flow, the who gets what, so that the CEO isn't getting 50-page technical specs and the engineers aren't just getting vague vision statements. It also allows for prioritization. By setting targets and measuring progress, you can see if your communication is actually working. Finally, it provides control. During the inevitable chaos of change implementation, a plan provides the order and structure needed to keep everyone calm and focused. So how do we build these frameworks? It starts with a set of core values. Let's explore the 7 principles that should guide every communication framework you create. If you want your communication to be more than just background noise, you need to build it on a foundation of proven principles. These 7 principles are the DNA of an effective strategy and plan. The first, and perhaps most important, is day 1 development. You don't wait until a crisis hits to start thinking about communication. You start the moment the project is conceived. Next, we have tailoring. Principles 2 and 3 emphasize that your communication must be bespoke. You must tailor it to your specific audiences and the immediate, unique needs of the project. There is no such thing as a one-size-fits-all template in complex project management. Principle 4 is about careful planning. This is the measure twice, cut once philosophy of communication. Once your plan is in motion, Principle 5 kicks in. Frequent reviews and feedback loops. You must constantly check if your message is landing and be ready to pivot. This leads directly to Principle 6. Flexibility. A rigid plan is a brittle plan. You must be able to adapt to changing circumstances. Finally, Principle 7 encourages the use of various methods. Don't rely solely on email. Use meetings, visuals, roadshows, and digital platforms to reach people where they are. Now, let's take a closer look at the first 4 principles, the ones that form the foundation and tailoring phase of your project. In the early stages of a project, the decisions you make about communication will echo throughout the entire life cycle. Let's break down these first 4 foundational principles. First, day 1 development. Start as early as the RFP stage to align owner expectations with what the supply chain can actually deliver. Second and third, bespoke communication. Tailor messaging to both your internal team and external stakeholders. Because what works for a regulator won't work for a site engineer, and every project has different dynamics. Fourth, careful planning, laser focus. Define exactly what people need to know, how often, and in what format to avoid costly rework later. With that foundation set, we can move to the final 3 principles focused on execution and adaptability. A plan that doesn't change is a plan that is already obsolete. Principles 5 through 7 are all about agility and methods. Principle 5 focuses on the feedback loop. You should be conducting frequent reviews to ask, is this information still timely? Is it still appropriate? If you find that stakeholders are ignoring your monthly newsletter but are very active in your Slack channel, your strategy needs to be updated based on those discoveries. Don't keep doing what isn't working. Principle 6 is flexibility. In complex projects with long life cycles, people change. You will face turnover among contractors, executive sponsors, and government officials. Legislation might change mid-project. Your communication framework must be robust enough to handle these shifts without collapsing. It needs to be an agile response system, not just a static document. Principle 7 is about using various methods to deliver your message. Think of it like a marketing mix for your project. You might use vision boards to keep the high-level goal in sight, message boards for daily tactical updates, and formal project status reports for the board of directors. You might even need roadshows, physical or virtual presentations, to reach local communities. Deploying a range of tools ensures that you catch different people in different ways. Now, when you sit down to actually develop this strategy, you can simplify the entire process by answering 3 core questions. Let's look at the what, who, and how. If you ever feel overwhelmed by the complexity of a project, take a step back and ask 3 simple questions. What, who, and how? These are the pillars of your communication strategy. The first question is, what? This is about the substance. What are we actually presenting? Is it a budget update? A safety warning? A milestone celebration? You must be crystal clear on the content before you do anything else. The second question is, Wei-Chu. Who is the target? You must distinguish between internal stakeholders, your team, your contractors, and external stakeholders, clients, the public, or regulators. A message that works for an internal engineer will likely fail if sent to an external community leader. The third question is how. How will the message be communicated? This is the medium or the channel. Should this be a face-to-face meeting for sensitivity? An email for a quick record? A video for broad engagement? Choosing the wrong channel can lead to the message being ignored, or worse, misinterpreted. Confidence in your project management comes from having tailored answers to these questions for every major phase. When you can answer these 3 things clearly, you have the foundation of a strategy. Next, let's look at a checklist of the specific objectives your strategy should aim to achieve. A communication strategy isn't just a document you have, it's a tool that does work for you. To make sure it's effective, we use this communication staff checklist of objectives. First, let's talk about the public. Your goal is engagement. You need to communicate the benefits of the project, why the city needs this new bridge, for example, but also acknowledge the impacts, like noise or traffic. Most importantly, you must listen to understand their concerns. This leads to expectation management. You need to keep people updated on environmental matters and potential impacts, so there are no nasty surprises. Next is media relations. In a complex project, the media will tell a story about you. Your strategy should focus on building relationships with journalists to ensure that story is accurate. Internally, your objective is knowledge. You want your staff to be project champions who can explain the project accurately to anyone they meet. Finally, we have perception management and accessibility. You want to reduce misunderstanding by providing the right detail at the right time. Too much info is as bad as too little, and you must ensure that information is accessible, clear, open, and always a two-way street. If the strategy is our high-level set of objectives, the plan is how we execute them. Let's move into the 8 key elements that make up a robust communication plan. Now we are moving from the blueprint into the map. A comprehensive communication plan must cover these 8 specific elements to ensure nothing falls through the cracks. It begins with identification. You must identify exactly who your target audiences and stakeholders are, and then, crucially, identify what they expect from you. Once you know the who and the expectation, you move to definition. You define your tools and methods, the how, and your target messages, the what. The next steps are about structure. Element 5 is classifying the type of communication. Is it formal or informal? Element 6 is establishing the forums and frequency. Where will we meet and how often? Element 7 is one of the most forgotten but vital steps, agreeing on the owner. Who is actually responsible for this specific communication? Finally, Element 8, branding guidelines. To build trust and recognition, your communication needs to look consistent. Whether it's an email or a formal report, it should carry the project's visual identity. In the next few slides, we will group these elements to see how they work together. Let's start with elements 1 through 4, the identification and definition phase. The first half of your communication plan is about precision. Let's look at how to get these first 4 elements right. Element 1 is target audiences. You aren't just sending a mass email, you are identifying specific recipients. This could be an individual, a group, or an entire company. A pro tip here is to use the RACI matrix: responsible, accountable, consulted, and informed. This tool helps you ensure that everyone who needs to know is on the list, and those who don't aren't being spammed. Element 2 is expectations. This is about empathy and planning. You need to determine what stakeholders expect to know. An investor wants to know about financial risks, while a local resident wants to know about road closures. Most importantly, you need to know when they expect that info. If you tell them about a road closure 5 minutes before it happens, you've failed. Element 3 is tools and methods. Establish your delivery mechanisms. Will this message work best as a video, a formal email, or a real-time teleconference? Match the tool to the urgency and the audience. Finally, element 4 is target messages. These are the must-lands. What are the specific key messages required to achieve your project objectives? If your objective is safety, your target message might be, "Zero harm is our only goal." Every communication should support these core pillars. Now that we've defined the content, let's look at how we execute and brand that content in elements 5 through 8. Execution is where many great strategies fail. Elements 5 through 8 of your plan are designed to ensure your communication is delivered professionally and consistently. Element 5 is type classification. You need to decide if a communication is formal, like a planned structured board report, or informal, like a quick update in a project chat room. Using the wrong type can send the wrong signal. You wouldn't announce a major budget cut in a casual hallway chat. Element 6 is forums and frequency. This is about the where and how often. What is the venue? Is it an article in the company newsletter, a town hall meeting, or a community roadshow? And what is the cadence? Is this a daily stand-up, a weekly update, or a quarterly review? Consistency in your frequency builds trust. Element 7 is the owner. You must determine who is best positioned to deliver the message. Sometimes the project manager is the right person. Other times, a technical expert or a community liaison might have more credibility with a specific audience. Assigning a clear owner ensures accountability. Finally, Element 8 is branding guidelines. This might seem superficial, but consistent use of logos, fonts, and colors creates instant recognition. When a stakeholder sees your project's branding, they should immediately know that the information is official, reliable, and part of a professional process. With these elements in place, how do we actually go about the development process? Let's look at 5 specific techniques to build a world-class plan. Building a plan is one thing, making it effective is another. These 5 techniques will help you move from a basic plan to a sophisticated communication system. Technique 1 is outlining timelines. Up front. This is about giving people the gift of time. When you share long-term project timelines early, you allow your stakeholders to plan their own long-term contingencies. This reduces stress and builds a partnership mindset. Technique 2 is related. Communicate disruptions. Early. Bad news doesn't get better with age. If you know a major intersection will be closed in 2 weeks, say it now. This enables your stakeholders to activate short-term contingency measures, like rerouting deliveries. Technique 3 is regular progress updates. Even if there isn't big news, regular updates build a track record of credibility and transparency. It shows you are in control and helps manage expectations over time. Technique 4 is mixing formal and informal styles. You need the structured, planned sessions for legal and safety reasons, but casual updates, like a quick team shout-out, keep morale high and information flowing naturally. Finally, Technique 5. Use creative media. We live in a visual world. Move beyond dense blocks of text. Use video, newsletters with infographics, and visual project dashboards. People are much more likely to engage with a 60-second video than a 6-page memo. This whole process is about creating long-term stability and success through anticipation and planning. But how do we know if it's working? We use feedback loops. In the world of agile project management, feedback is fuel. We use iterative feedback loops to identify gaps in our communication and drive continuous improvement. There are 4 types of loops you should be aware of. First is the positive loop. This is when you receive constructive feedback that actually helps the project advance. For example, a client might suggest a more efficient way to report data. This inspires action and keeps the momentum going. Second is the negative loop. Now, negative doesn't mean bad. In technical terms, a negative loop identifies a gap, or a delta, the difference between where you are and where you should be. If stakeholders don't understand the new safety protocol, that's a delta. You then need an action plan to reduce the delta and bring them up to speed. Third is the internal loop. This happens inside your team. You should be constantly reviewing your own work, ensuring quality, and, most importantly, challenging each other's approaches. Is there a better way? Is this message clear? Finally, the external loop. This is proactive. You don't wait for stakeholders to complain. You seek their input during the planning phase. This makes them feel like partners and helps you catch potential issues before they become crises. These loops aren't just for the start of the project. They must happen throughout the entire life cycle. Let's look at how feedback integrates into conception, design, construction, and operation. A common mistake in project management is thinking that communication is a one-and-done task. In reality, it is a continuous flow that changes focus as the project matures. In the early stages, project conception and design, we use value engineering. This is a structured communication process where we ask, how can we deliver the same or better function at a lower cost? It requires intense collaboration between owners and designers. As we move into construction, a different kind of feedback loop becomes critical. Buildability. This is when the people actually building the project provide feedback to the designers and planners. They might say, the design looks great on paper, but we can't physically get the crane into that space. This feedback must flow back to the design and conception stages to allow for adjustments before they become expensive mistakes. Finally, once the project is finished and in the operation stage, we have the post-occupancy evaluation. This is where we learn from the end users. Does the building work as intended? Is the software user-friendly? This feedback is gold. It flows all the way back to the beginning of the next project's conception phase. By maintaining these loops, we turn every project into a learning machine. And the benefits of this aren't just feel good, they are measurable. Let's look at the quantitative and qualitative benefits of good feedback. When you're trying to convince a skeptical sponsor to invest in a better communication system, you need to speak their language. That means showing them both the hard numbers and the soft yet vital improvements. On the quantitative side, the things we can measure with a calculator, the benefits are clear. High-quality feedback loops lead to reduced engineering and construction costs. When you catch a design error early through a feedback loop, you save thousands, if not millions, in wasted materials and labor. You also see a shorter schedule duration. Clear communication means fewer delays, faster approvals, and a quicker path to the finish line. On the qualitative side, the things that are more subjective but no less important, we see a massive impact on the project's health. We see improved safety because everyone knows the risks and protocols. Site accessibility is better because disruptions are managed. We see reduced rework because things are done right the first time. Perhaps most importantly, good feedback leads to increased team commitment. When people feel heard, they are more engaged. This leads to a smoother startup when the project is finally handed over to the client. However, there is a catch. Not all feedback is good feedback. In fact, if you do it wrong, you can actually make performance worse. Let's look at what the science says about effective versus ineffective feedback. Here is a shocking statistic that every project manager needs to memorize. 1/3 of all feedback actually has a negative impact on performance. If you are giving feedback the wrong way, you are literally paying people to do a worse job. So, what is ineffective feedback? It's feedback that is too general. Even positive feedback like, "Great job, team," can be ineffective because it doesn't tell people what they did right so they can repeat it. Likewise, focusing solely on motivation. We can do this, without providing technical direction, can actually lead to frustration and confusion. Effective feedback, on the other hand, is laser-focused on task specifics. It addresses exactly what worked and what didn't regarding a specific deliverable. It's not about the person, it's about the task. It focuses on learnings that can be applied immediately to the next task. When you provide specific, task-oriented feedback, you do something more than just improve the work. You build trust. Your team learns that your feedback is a tool for their success, not a personal judgment. As you prepare for your certification exam, these distinctions are crucial. Let's look at the key concepts you need to remember. As we approach the end of this module, I want to highlight the must-know concepts for your PMI-CP exam. These 6 points represent the core takeaways of our session. First, you must be able to differentiate between the strategy and the plan. Remember, the strategy is your day one blueprint, the why and what. The plan is your map, the tactical how and when. Second, remember the failure rate. 33%, 1/3, of mega projects fail specifically because of communication issues. This highlights the high stakes of the frameworks we've discussed. Third, memorize your key principles. If you're asked what makes a strategy effective, the top 3 answers are: it's tailored to the audience, it starts on day one, and it is flexible. Fourth, don't be tripped up by the term negative feedback loop. In this context, it isn't bad news. It's a technical process of identifying a gap, or delta, so you can close it. Ever been on a project that's pulling in 10 directions, teams confused, stakeholders sidelined? The problem is often communication, not technical skill. In this session on building effective frameworks for complex projects, PMI-CP will clarify a key difference: communication strategy versus communication plan. The strategy defines the why and what. The plan defines the who, how, and when. For complex infrastructure, IT, or major change projects, mastering both is essential. Fifth, know where things belong. A branding or style guide is a specific element of the plan, not the high-level strategy. Finally, remember the rule for timelines. They must be shared up front. This isn't just a courtesy. It is a technical requirement for effective contingency planning by your stakeholders. Have you ever wondered why some multi-million-dollar projects finish under budget while others become legendary financial disasters? The answer often lies not in how the project was built, but in how it was planned before the first shovel ever hit the dirt. Welcome to Lecture 9 of our PMI-CP exam preparation course. Today we are diving deep into the world of front-end planning and scope management. This isn't just about making a list of tasks. It's about setting the project up for success by establishing a clear, immutable scope from day one. First, we will look at the architecture of a project's early life. On this slide, you see a preview of the project definition process. It's a workflow that connects project phases to scope definition and eventually into scope dictation. This matters because if you don't define the boundaries of your project early, the project will define them for you, usually through expensive delays. We will examine how the scope definition process interacts with estimating and surveying to create a solid foundation. Next, we'll transition into why this strategic phase is often called pre-construction. It is the moment where we address risks and commit our most valuable resources. Throughout this lecture, we'll treat scope as the North Star of project governance. If the scope is vague, your budget and schedule will be too. Now let's get clear on exactly what you need to master for the exam. This module is designed to give you the analytical tools to justify front-end investment to any stakeholder or exam board. What is the specific value of planning? Many project managers struggle to justify the time spent on front-end work when leadership wants to see physical progress. By the end of this module, you will be able to speak the language of statistics and logic to defend your planning phases. First, we will analyze the statistical impact of front-end planning. We aren't just guessing. Data shows that early scope definition correlates to a 20% savings in cost and a 39% savings in schedule. For the exam, these numbers are your best friends. Next, we'll tackle a common point of confusion: the difference between project scope and the scope of services. One is holistic and end-to-end, while the other is a narrow contractual obligation. Distinguishing these correctly is vital for avoiding the claims gap that plagues complex projects. We will also master the 100% rule. This rule is the standard for validating a work breakdown structure, or WBS. It ensures that internal, external, and even soft interim deliverables are captured. If it's not in the WBS, it doesn't exist in the project budget. Then, we will look at the McCleamy curve. This curve is a logical tool used to justify why late stakeholder changes are so dangerous and why they must be formally managed. Finally, we'll navigate the governance of the scope baseline. You need to know exactly what components make up a baseline and the protocols required to change it. This knowledge will help you navigate the trickiest choose the best action questions on the PMI-CP exam. This leads us to our first core concept, the strategic phase known as front-end planning. Why is early scope definition non-negotiable? The McCleamy curve explains the physics of project management. On the vertical axis, we have effort and cost. On the horizontal, we have project time, moving from pre-design all the way to operation. Look at the green line, your ability to impact cost and functional capabilities. It is at its absolute peak on day one. At the start of a project, you can change the entire layout of a building with a pencil and an eraser for almost zero cost. However, notice the purple line. The cost of design changes. As time moves to the right toward the construction and operation phases, the cost of making a change skyrockets. If you decide to move a wall during the concept phase, it's free. If you decide to move that same wall once the concrete is poured and the plumbing is installed, it becomes exponentially expensive. This is why the preferred workflow, often associated with integrated project delivery or FEP, is to shift left. Signposting our goal. We want to move the bulk of our intellectual effort upstream to the left of the curve. This shift left strategy ensures we make the most impactful decisions while they are still cheap. As an exam insight, remember this: changes made during the execution phase are a nightmare scenario. You face the highest possible costs with the lowest possible influence. If a question asks how to reduce risk, the answer almost always involves moving activities earlier in the timeline. Now that we understand the timing, let's look at the what. We need to distinguish between the two primary ways we define scope. In the world of professional contracting, scope is a word that can mean two very different things depending on who is talking. For the exam and for your career, you must distinguish between the holistic view and the contractual view. First, let's look at project scope. This is the big picture. It is the end-to-end view of every single activity required to deliver the final asset. This includes the hard construction work, but also soft items like regulatory approvals, environmental mitigation, and the operational outcomes the owner expects. Most importantly, project scope defines the boundaries. It tells everyone exactly what is in and what is excluded. It visualizes the owner's need. Next, we have the scope of services. This is a contractual document specific to a single entity, such as an architect, an engineer, or a general contractor. It details the specific deliverables that the entity is legally obligated to provide. It is a subset of the larger project scope and visualizes the vendor's obligation. Here is your exam warning. Claims, disputes, and finger-pointing almost always happen in the gap between these two. For example, if the project scope requires environmental permits, but the owner forgot to include that in the architect's scope of services and the contractor's scope of services, you have a gap. The work is required for the project, but no one is contractually obligated to do it. As a project manager, your job is to ensure the aggregate scope of services, the sum of all contracts, perfectly covers the entire project scope. To manage this effectively, we need a governance standard. Let's look at the 3 pillars of the scope baseline. How do we measure performance in a way that is fair and legally defensible? We use the scope baseline. This is the governance standard for your project. Think of it as a 3-legged stool. If one leg is missing, the whole thing falls over. The first component is the project scope statement. This is the narrative. It describes the deliverables in plain English and, crucially, lists your assumptions and constraints. If you assume the owner will provide the land cleared of debris, that must be written here. The second component is the work breakdown structure, or WBS. This is a hierarchical decomposition. We take that big narrative and break it down into smaller, manageable chunks of work. It's the skeleton of your project. The third component is the WBS dictionary. If the WBS is the what, the dictionary is the how, who, and how much. It provides the detailed information for each WBS element, including the budget, the schedule, and the party responsible for delivery. Now, pay close attention to the governance rule. Once these 3 items are approved and signed off, the baseline is locked. It is no longer a work in progress. From that moment forward, any change, no matter how small or how essential, can only be implemented through formal change control procedures. As the slide notes, without a formal sign-off, it isn't a baseline. It's just a draft. For the exam, if a question asks about measuring performance, you are measuring it against this approved, locked baseline. To build a great baseline, you need a high-quality scope of work. Let's look at the best practices for developing one. A poorly written scope of work is a gift to a contractor looking for a change order. To reduce ambiguity and protect the project, you need to follow these best practices. First, use clear language. Avoid jargon that could be misinterpreted in court. A key legal principle to remember for the exam is that ambiguity favors the non-drafting party. If the owner writes a vague SOW and the contractor interprets it in a way that is cheaper for them, a judge will often side with the contractor because the owner had the chance to be clear and failed. Use a glossary for technical terms. Next, use a breakdown. Use a top-down approach. Start with the high-level owner goals and decompose them into specific, actionable tasks. This ensures that every task on the ground actually serves a higher project purpose. Then, solidify objectives. A goal like high quality is useless. Instead, ensure every objective is tied to a measurable deliverable. For example, instead of good paint job, specify 3 coats of ASTM standard X paint. We also highly recommend using visuals. A diagram or a map showing battery limits, the physical boundaries where one contractor's work ends and another's begins, is often more effective than 10 pages of text. Finally, none of this matters without the sign-off. Mandatory, formal approval from all stakeholders is the only way to lock the baseline. If a stakeholder says, "I'll look at it later," the PM must pause and get that signature. This leads us back to the work breakdown structure. Let's talk about the most important rule in scope management, the 100% rule. The work breakdown structure is the deliverable-oriented hierarchy of your project. But how do you know if your WBS is complete? You apply the 100% rule. This rule is absolute. The WBS must include 100% of the work defined by the project scope. If a task or a cost is required to finish the project, it must have a home in the WBS. This includes the obvious hard deliverables like foundation or electrical, but it also includes internal, external, and interim deliverables. Crucially, the 100% rule includes project management and soft costs. Many teams forget to budget for the time spent in meetings, the cost of permits, or the expense of temporary utilities. As the slide says, if it is not in the WBS, it is not in the project. For the exam, remember that the WBS is about deliverables, not necessarily just actions. To ensure your WBS is high quality, check it against these WBS principles. Is every element definable? Is it manageable by one person or team? Is it estimable in terms of time and money? We also want elements to be independent, meaning they don't overlap with other chunks of work, and integrable, so they can be combined into the final project. Finally, they must be measurable, so we know when they are done, and the structure should be adaptable to changes through formal control. Let's see how this rule works in a real exam-style scenario. Here is a classic scenario you might face on the PMI-CP exam. You are the PM for a new commercial complex. Your team is eager to start and submits their WBS for your approval. As you review it, you notice that major items like project management, permitting fees, and temporary utilities are missing. When you point this out, the team pushes back. They argue these are just overhead and don't need to be in the WBS because they aren't physical deliverables like walls or floors. Signposting the conflict. Because these items are missing, your current budget and schedule estimates are artificially low. You are essentially lying to the owner about the project's true cost. What is the best course of action? Should you just add a management reserve to cover it? No. Should you manage it via general conditions clauses? No. The correct action is to reject and revise to adhere to the 100% rule. Why? Because as we just learned, the 100% rule dictates the WBS must contain all work. If these items aren't in the WBS, they won't be assigned a responsible party, they won't be resourced, and they won't be on the schedule. This is a recipe for a guaranteed cost overrun the moment the first permit bill arrives. In the exam, always choose the path that enforces the 100% rule and baseline integrity. This reinforces why we need everyone on the same page from the start. Let's look at how to bridge the operational gap with stakeholder buy-in. A project can be technically perfect, but still be a failure if the person who has to run it wasn't consulted. This is called the operational gap. We often see projects where the owner, the architect, and the engineers are in perfect alignment during design and construction, but the facility manager, the person who will actually operate the building, is ignored until the day of handover. Signposting the risk. This leads to the McLeamy risk of late changes. If the facility manager walks in during construction and says, This doorway isn't wide enough for our maintenance equipment. You are now in the exponentially expensive purple line zone of the McCleamy curve. To avoid this, you must engage end users and facility managers here during the concept and design phases. Here is an exam insight. If you see a scenario where a conflict arises late in the project between what the business wants and what the operations team needs to actually function, the root cause is almost always failed stakeholder analysis during the concept phase. You missed a key player early on, and now the project is paying the price. Don't let the operator be a stranger to your scope definition. To see the devastating impact this can have, let's look at one of the most famous project management failures in history, the Denver International Airport. Denver International Airport, or DIA, is the poster child for what happens when you ignore the principles of FEP and stakeholder engagement. Originally budgeted at $3 billion, it ended up costing $4.8 billion, a staggering $1.8 billion overrun. It also opened 16 months late. From a scope perspective, why did this happen? First, there was late engagement. The major airlines, like United and Continental, were the operators of the airport, yet they weren't fully consulted until after the design was already complete. When they finally got involved, they demanded massive changes to suit their operational needs. Second, this led to massive scope creep. Mid-construction, the project added a requirement for a revolutionary, highly complex automated baggage system. Third, there was a governance failure. The project leadership underestimated the complexity of these changes and didn't have the strict controls needed to manage them. As the slide notes, this is the purple line of the McCleamy curve in action. Changes in execution are exponentially expensive. The lesson for the exam is clear. Engage your most powerful stakeholders early, or they will break your budget later. Now, let's look at how a PM should handle a high-pressure request for a must-have upgrade during construction. In this exam scenario, you are building a hospital wing. Mid-construction, the chief of surgery, a very powerful stakeholder, demands a new robotic surgery system. She tells you it's essential for patient safety. However, this system requires massive rework of electrical and structural work that your team has already finished. This is the ultimate test of a PM's backbone. You have a high-power request clashing against a frozen scope baseline, signposting the analysis. What do? Some might say, it's for safety, so just do it. Others might say, the baseline is frozen, so just say no. Both are incorrect. The correct action is to process this through the formal Change Control Board, CCB. Why? Because according to PMI rules, even for an essential or safety item, a project manager cannot unilaterally alter the baseline during execution. Your role is to be a neutral analyst. You must analyze the impact on the triple constraint. How much more will it cost? How much longer will it take? What other scope will be impacted? Then you present this analysis to the governance body, the CCB, and let them decide if the added value justifies the massive cost penalty. You protect the baseline. The governance body decides when to change it. This leads us to the formal process for changing that baseline. Governance is the who has the authority part of your project. When a scope change request is received, the first question we ask is, does it alter the baseline? We check cost, schedule, and deliverables. If the answer is no, for example, it's just a clarification of an existing requirement, then the PM or a lead engineer can approve it. This keeps the project moving without unnecessary bureaucracy. However, if the answer is yes, we enter the formal modification path. This leads to the formal change control process. This involves a detailed analysis of the impact, followed by a review from the Change Control Board. Only once it is approved and signed off is the baseline officially updated. Here is the PMI-CP rule you must remember. Without that formal sign-off, you are working at risk. If you start the work because the client promised they would pay for the change later, you have failed as a PM. Informal scope creep, often called handshake deals, is considered a failure of governance. For the exam, always follow the flow. Analysis first, then CCB review, then sign-off, then work begins. Finally, let's look at the most common traps and misconceptions that lead to scope failure. To pass the exam, you must recognize these 3 patterns of failure. The first is gold plating. This is when a team member adds extra features or fancier materials to please the client, even though the client didn't ask for them. The exam verdict is that this is always incorrect. It might seem like good customer service, but it creates unapproved costs and, more importantly, creates legal liability. If that unrequested extra feature fails, the project is 100% liable. The second trap is ignoring soft scope. This is exactly what we saw in our WBS gap scenario. Leaving project management, permitting, or safety oversight out of the WBS is a direct violation of the 100% rule. If the work is required to deliver the project, it belongs in the WBS. The third trap is vague acceptance criteria. This is the primary source of disputes in construction and engineering. If your SOW defines success as high quality, you have invited a claim. High quality is an opinion. You must instead use technical standards, such as ASTM Standard X. If it's not measurable, it's not a good criterion. Now, let's wrap everything up with a final summary. We have reached the end of Lecture 9 on front-end planning and scope management. If you take nothing else away, remember these 5 pillars. First, invest upfront. Front-end planning is the single biggest predictor of project success, with massive potential savings in both cost and time. Second, respect the curve. Internalize the McLeamy curve logic. Shift left. Make your most difficult decisions when they are still cheap. Third, define clearly. Your scope baseline is your shield. Use the statement, the WBS, and the dictionary together, and never compromise on the 100% rule. Fourth, engage early. Don't forget the facility managers and end users. As we learned from the Denver airport case study, involving them during construction is far too late and far too expensive. Finally, govern strictly. A baseline is only a baseline if it is protected. All changes, no matter how small or essential, require formal analysis and sign-off. If you follow these principles, you'll not only pass the PMI-CP exam, but you'll also build a reputation as a PM who delivers exactly what was promised. Have you ever wondered why some multi-million-dollar projects finish under budget while others become financial disasters? The difference is often decided before construction starts. Welcome to our session on scope definition and the work breakdown structure, a core PMI-CP topic for construction professionals working in high-stakes environments. We begin with front-end planning, FEEP, where scope becomes the North Star of governance. If scope is unclear, budget and schedule will be unclear too. You will see how the process moves from project definition to firm scope boundaries, creating a solid foundation for every deliverable. A project without boundaries rarely finishes cleanly. Next, we focus on why this stage is often called pre-construction. This is where risks are identified early, resources are committed wisely, and technical expertise has maximum impact, preventing failures before they become expensive realities. Finally, we connect this directly to the exam and to real project outcomes. You will gain practical tools to justify front-end investment, manage decision-making confidently, and apply disciplined scope practices that protect cost, time, and asset performance. What is the specific value of planning? Many project managers struggle to justify the time spent on front-end work when leadership wants to see physical progress on the ground. By the end of this module, you will be able to speak the language of statistics and logic to defend your planning phases. We have 5 core objectives that will transform how you approach project boundaries and lead to much more predictable project outcomes. First, we will look at strategic impact. We aren't just guessing that planning helps. We are going to quantify exactly how much. We'll look at data showing how early scope definition correlates with massive savings in both cost and time. Next, we'll tackle scope architecture. A common point of confusion in the industry is using terms like project scope and scope of services interchangeably. We will define the nuances of each to ensure your contracts are airtight and your professional communication is precise. Understanding these differences is the difference between a smooth handover and a legal dispute. Then we move to technical execution. We will master the work breakdown structure, or WBS, and apply the famous 100% rule. This rule is the standard for validating that your project skeleton is complete. We will also look at stakeholder alignment through a high-profile case study, the Denver International Airport. This will serve as a warning of what happens when you skip early engagement. Finally, we'll tie everything together with exam logic. This certification is about more than definitions. It's about mastering choose the best action questions regarding governance and risk. This matters because, as a project leader, you are the steward of the project's vision. If you can't define the objectives clearly, you can't lead the team to a successful finish. By focusing on these 5 pillars, you will develop the mental framework needed to spot scope gaps before they become schedule delays. Let's start by building the financial case for our first core concept. Imagine trying to navigate a ship across the Atlantic by only looking at the horizon. You might make it, but you'll likely hit a storm you could have avoided with a proper map. Front-end planning, or FEP, is that map for your project. For the exam, you need to know that FEP, also known as front-end loading or pre-construction, is the technical process of developing enough information to manage risks before you commit the bulk of your resources. It is the bridge between a business idea and a technical design. Signposting the process is key. FEP happens in 3 distinct stages. First is stage 1, feasibility, where we appraise the situation. We ask the brutal question, is this project actually viable, using benchmarking and option analysis? Next is stage 2, concept, where we select. This is where we choose the specific strategy we will take, supported by conceptual design and ROI analysis. Finally, we reach stage 3, detailed scope, where we define. This is where project goals are finalized and we prepare the project execution plan. By the end of this stage, you should be fully ready for design, with all major uncertainties addressed. Now, why does this matter so much? Look at the research from the Construction Industry Institute. Effective FEP can reduce project costs by an average of 20% and slash schedule duration by nearly 40%. These aren't just minor improvements. They are the difference between a project being a success or a bankruptcy risk. For an engineer, failing to do FEP is like building a skyscraper without a geotechnical survey. You might get several floors up before the foundation begins to sink and the costs spiral out of control. The bottom line is clear. Projects with insufficient FEP are statistically likely to fail. They suffer from rework, change orders, and stakeholder friction because the team is trying to figure out the what, while they are already doing the how. To understand why these savings happen, we need to look at the physics of project timing and the exponential cost of making mistakes. Why is early scope definition non-negotiable? The McLeamy curve explains the fundamental economics of project management. On the vertical axis, we have effort and effect. On the horizontal, we have the project phases, moving from pre-design all the way to operation. Understanding this curve is vital for the exam because it proves why shifting left is the only logical way to manage a project. It demonstrates that time is not just a schedule component, it is a form of currency. First, look at the green line. Your ability to impact cost and functional capabilities. It is at its absolute peak on day 1. At the start of a project, you can change the entire layout of a building with a pencil and an eraser for almost zero cost. As an engineer, your influence is greatest when the project is just lines on a page. However, notice how that ability drops sharply as we move into the construction phase. By the time concrete is poured and steel is erected, your ability to make impactful changes is almost gone. Now look at the inverse, the cost of change. It starts low, but increases exponentially as time goes on. If you decide to move a wall during the concept phase, it's free. If you decide to move that same wall once the plumbing and electrical have been installed, it becomes a financial disaster. This is where most traditional projects fail. They resolve conflicts late in the timeline where the cost is highest. The preferred workflow, associated with integrated project delivery or heavy FF, involves moving the bulk of your intellectual effort upstream to the left to avoid these costs. As an exam insight, remember this. Changes made during the execution phase are a nightmare scenario. You face the highest possible costs with the lowest possible influence. If a question asks how to reduce risk, the answer almost always involves moving activities earlier in the timeline to maximize your influence. Now that we understand the when, let's clarify the what of our scope documents. In the world of professional contracting, scope is a word that can mean very different things depending on who is talking. For the exam in your career, you must distinguish between the whole and the part. Many claims and disputes arise simply because people use these terms interchangeably when they shouldn't. This precision in language is what separates a professional manager from a layperson. Let's start with project scope, or the whole. This is the holistic, end-to-end view of every single activity required to deliver the final asset. This includes the hard construction work, but also soft items like regulatory approvals and operational outcomes. Most importantly, it defines the boundaries. It tells everyone exactly what is in and what is out or excluded. It visualizes the owner's need. If you are building a bridge, the project scope includes the environmental permits. If you forget them, the project stops, regardless of how much steel you've already bought. Next, we have the scope of services, or the part. This is specific to a single entity, like an architect or a general contractor. It is the contractual obligation for that one single party. It is a subset of the larger project scope. Now, here is your exam warning. Claims almost always happen in the gap between these two. For example, if the project scope requires site security, but the owner forgot to include it in the GC's scope of services and the architect's scope of services, you have a gap. The work is required for the project, but no one is contractually obligated to do it. Finally, we have the scope of work, or SOW. This is the narrative document itself, the manual for the work. It details objectives, outcomes, and granular deliverables. A high-quality SOW reduces ambiguity and protects the project from opportunistic claims by being as specific as possible. To manage this effectively, we need a governance standard. Let's look at the 3 pillars of the scope baseline that keep everything on track. How do we know if a project is winning or losing? We measure it against the scope baseline. For engineers and project leaders, the baseline is the immutable standard, the yardstick for performance measurement. For the exam, you must remember that a baseline is not just one document. It is a set of 3 specific pillars that must be approved and locked. This serves as the foundation for all future control and reporting. The first pillar is the project scope statement. This is the narrative description. It describes the deliverables in plain English, and crucially, lists your assumptions and constraints. If you assume the owner will provide the land cleared of debris, that must be written here. The second pillar is the work breakdown structure, or WBS. This is the hierarchical decomposition. We take that big narrative and break it down into smaller, manageable chunks. It is the skeleton of your project, showing how every part relates to the whole. The third pillar is the WBS dictionary. If the WBS is a box labeled electrical, the WBS dictionary is the note inside the box that tells you the specific budget, the required schedule, and the technical specifications for that task. It provides the detailed metadata that makes each component actionable and verifiable. Without the dictionary, you might build the right thing, but at the wrong cost or to the wrong quality standard, leading to failure. Here is your critical exam insight. You cannot measure performance, specifically earned value, without a fixed scope baseline. Think of it like a race. If the finish line keeps moving, you can't measure how fast you're running. Once these 3 items are approved, they are locked. Any change, no matter how small or seemingly essential, can only be implemented through formal change control. Without that final sign-off, you don't have a baseline, you just have a draft. Now let's look closer at the WBS principles. What exactly is a work breakdown structure? A common mistake, even among experienced professionals, is thinking the WBS is a to-do list or a schedule. It is not. The WBS is a deliverable-oriented hierarchy. It focuses on what is being built, not the actions taken to build it. For example, installing pipe is a task. The piping system is the deliverable. Your WBS should be made of deliverables because that is what the client is ultimately paying for. To ensure your WBS is high quality, you should check it against these 7 principles. Every element must be definable. You should be able to explain what it is in 1 sentence. It must be manageable, meaning you can assign it to one person or team and hold them accountable for its completion. It must be estimable. You can't manage what you can't price or schedule. Next, elements should be independent. There shouldn't be overlap between boxes. If 2 different contractors think they are responsible for the same work, you have a conflict waiting to happen. Elements must also be integrable, meaning they fit together into the final project, and measurable so you know when they are 100% complete based on objective facts rather than a feeling. Finally, the structure must be adaptable to changes through formal governance. This matters because a messy WBS is the root of most cost overruns. If you don't know exactly what goes in each box, you'll end up double counting work, or, worse, missing work entirely during the estimate. This leads us to the most important rule in all of scope management, the 100% rule. Let's look at how to ensure your project skeleton is complete and captures all required effort, including the things that are often overlooked until it's too late. How do you know if your WBS is actually finished? You apply the 100% rule. This rule is absolute. The WBS must include 100% of the work defined by the project scope, no more and certainly no less. If a task or a cost is required to finish the project, it must have a home in the WBS. This isn't just a suggestion. It is the mathematical foundation of your project control and is a key concept for the certification exam. The logic is simple. The sum of the children must equal 100% of the parent. If Phase 1 is a parent box representing 40% of the project, the deliverables inside it must add up exactly to that 40%. This matters because it captures things many teams forget, the soft costs. Does your WBS include project management, permitting fees, temporary utilities? If it is not in the WBS, it is not in the project, which means it won't be resourced, scheduled, or budgeted. There are 2 primary ways to violate this rule. The first is an omission, where the sum is less than 100%. This creates a scope gap. You've forgotten something essential, which guarantees cost overruns later. The second violation is the inverse, gold plating, where the sum is more than 100%. This is when unnecessary work is added that the client didn't ask for. It might seem like a bonus, but it consumes resources and adds liability that hasn't been approved by the stakeholders. For the exam, remember this. The WBS must be an airtight representation of the total project effort. If you find something in your estimate that doesn't have a home in the WBS, you have a violation of the 100% rule. Let's look at a practical exam scenario to see how a scope gap looks in a real-world decision-making context and how you should respond as a professional. Let's look at a scenario that keeps project managers up at night. You are managing a commercial complex, and during excavation you hit a high water table. The contractor stops work and claims that dewatering, pumping out water so digging can continue, is not in their scope of services. They point out that the soil report was provided by you, the owner. You look at the SOW, and it says they must perform all necessary excavation, but doesn't explicitly use the word dewatering. What is the best course of action? A common mistake is to pick option 1, simply direct them to do it. But that could lead to a massive legal claim if they are right. Another mistake is option 2, immediately pay them a change order. This is a failure of governance. You might be paying for something they were already supposed to do. Option 4, checking the McCleamy curve, is a nice thought, but doesn't help you solve a current contractual dispute between parties. The best action is option 3, review the scope of services, the SOW, and the risk register. Why? Because before you assume financial liability or enforce work, you must verify the specific contractual boundaries. Ambiguity requires a governance review, not an emotional reaction. This matters because if the risk of dewatering was identified in the risk register but left out of the SOW, you have a governance gap that needs addressing before the project can move forward safely. This scenario reinforces why front-end planning is so critical. If the WBS and SOW had been detailed enough during the planning phase, this argument would have a clear, pre-agreed answer. Now, let's see a legendary real-world case study where failed stakeholder alignment and scope gaps led to a multi-billion-dollar disaster. What happens when you ignore the shift-left principle of the McCleamy curve? You get the Denver International Airport, or DIA. This project is a legendary warning for every project manager. Originally intended to be a modern marvel of efficiency, it opened 16 months late and cost $4.8 billion, nearly $2 billion over its original budget. For the exam, you need to understand the root causes of this failure to avoid repeating them in your own projects. The primary root cause was a failure in stakeholder timing. The project team made the fatal mistake of getting stakeholder buy-in during the execution phase rather than the feasibility phase. Specifically, they engaged the major airlines, the people who would actually use the airport, after the design was already 100% complete. This is the absolute peak of the cost of change curve, where every adjustment, no matter how small, is exponentially expensive. The results were catastrophic. United Airlines demanded a massive, complex automated baggage system while the airport was already being built. Continental Airlines demanded an entirely new concourse and a bridge late in the game. Because the project was at risk of losing its anchor tenants, the leadership agreed to these late changes. The lesson for the exam is non-negotiable. You must identify and engage your end users and facility managers during front-end planning. If you wait until construction, their needs become your emergencies. This matters because, as a technical professional, you are the bridge between the client's dream and the physical reality. If you don't bring the dreamers and the operators together early, you will be the one trying to fix the cracks when they collide later. Let's look closer at the specific technical scope gaps and engineering failures that crippled the airport's progress. The failure at Denver wasn't just about big concourses. It was about granular technical omissions that cascaded into massive delays. Let's look at two specific examples. First, the baggage system. It was added late as a scope change, and its technical complexity was drastically underestimated. When it finally came time to turn it on, the system failed completely, shredding bags and crashing software. The airport was forced to use manual workarounds, which contributed significantly to the 16-month delay. This is what happens when you bolt on a complex requirement late. Second, let's look at the Tracon building. During construction, engineers discovered massive cracks in non-weight-bearing walls. The cause was a simple scope omission. The design was missing slip joints. In Colorado's expansive soils, buildings need to move slightly. Without those slip joints, the building essentially tried to tear itself apart as the soil shifted beneath it. The repair cost was $175,000 for the walls alone, not to mention the schedule impact and the damage to the project's reputation. The critical exam application here is the necessity of constructability reviews. This is a form of scope validation where you ask, can we actually build this as designed? If the DIA team had performed a rigorous constructability review with geotechnical experts and systems engineers during FEP, the missing slip joints and the baggage system complexity would have been identified while the cost of change was still low. Missing a review is a choice to pay for rework later at a much higher price. This leads us to 3 common scope mistakes you must recognize on the exam to avoid these same pitfalls. Let's look at the patterns that lead to project failure and how to spot them in professional environments. On the exam, you will face questions designed to trick you into being helpful or reasonable at the expense of the project baseline. You must resist these temptations. There are 3 specific patterns of failure you need to recognize to maintain professional governance and protect your project. The first is gold plating. This is when you give the customer more than they asked for just to be nice or to build a better relationship. In professional project management, gold plating is strictly prohibited. Why? Because it adds costs the client hasn't approved, and more importantly, it adds liability. If you add a free upgrade and it fails, you are 100% responsible for the damages. You have introduced risk to the project with zero value to the project's authorized objectives. It is a violation of the fiduciary duty you have to the project budget. The second is scope creep. This is the uncontrolled addition of changes without any adjustment to the project's time, cost, or resources. Scope creep is the silent killer of projects. It happens one small favor at a time until the project is months behind and millions over budget. It represents a fundamental breakdown in the change control process. The third is vague language. This is the primary source of disputes. Avoid words like approximate, customary, or as necessary in your SOWs. For an engineer, these words are meaningless and dangerous. Instead, you must use quantifiable metrics. Don't say approximate temperature. Say maintained at 72 degrees Fahrenheit plus or minus 2 degrees. This matters because you cannot manage what you cannot measure, and you cannot enforce a contract that uses subjective language. Let's look at an exam scenario involving a helpful team member to see if you can spot the violation of these principles and choose the correct professional response. Here is a classic trick question you will likely see in some form. To improve client relations, your site superintendent decides to be helpful. He upgrades the lobby flooring from standard tile to high-end marble. He tells you not to worry because he's using leftover material from another job, so there is no extra cost to the client. It sounds like a win-win, right? Wrong. What should you do? Option 1. Praising him for adding value is the intuitive human response, but it is the wrong project management response. Option 4, ignoring it because there's no budget impact, is equally dangerous. The best action is option 2. Report this as a scope violation and assess the risk. You must treat this as a serious breach of project protocol. Why? Because this is a textbook case of gold plating. Even if the material was free, the project is now at risk. Marble has different load-bearing requirements than tile. Will the subfloor support the extra weight over 10 years? It has different maintenance requirements. Did the client budget for expensive marble sealants? It has different safety risks. Is it more slippery when wet? By changing the scope without approval, the superintendent has created massive potential liability. The rule is absolute. All scope changes, even free ones, require formal approval from the governance body before implementation. This matters because it reinforces the role of the PM as the guardian of the baseline. You aren't there to be popular. You're there to ensure the project delivers exactly what was promised. Now let's look at the mandatory order of operations for when a change is requested the right way. When a stakeholder asks for a change, your first reaction defines your success as a project manager. On the exam, you will often be asked, what do you do first? The answer is never, implement it or reject it right there on the spot. The answer is always, analyze. This disciplined approach is what prevents scope creep and ensures the project remains viable. This is the mandatory order of operations. The trigger is the request. Your first step is to consult the scope baseline and the WBS to see exactly how this change deviates from the authorized plan. Next, you evaluate. You must determine the impact on the triple constraint. How does this change affect the cost, the schedule, the risk profile, and the quality of the project? You cannot make a professional recommendation to the client or the board without these facts. Step 3 is to process. You submit a formal change request to the Change Control Board, or CCB. You present your evaluation and the hard data. Finally, step 4. The CCB or the client makes the final decision. You are the analyst. They are the authority. The non-negotiable rule for the exam: do not immediately say no or yes. Saying yes leads to scope creep. Saying no without analysis is a failure to manage stakeholder needs effectively. This process ensures every change is a documented business decision, not an emotional reaction on the job site. This matters because it protects you, the project, and the organization's resources. Now let's wrap up and summarize the core principles you need to carry into your exam and your next multi-million-dollar project. We've reached the end of our session on front-end planning and scope management. The key takeaway is simple. Project success is decided early. Strong front-end planning protects cost, schedule, and performance. Your scope baseline, the scope statement, WBS, and dictionary, is your primary defense against disputes. If something is not in the WBS, it is not part of the project. Engage stakeholders early, especially end users, while changes are still low cost. Maintain strict governance and avoid informal changes or gold plating. Every change must follow formal control. These principles are not only critical for the PMI-CP exam, they define effective project leadership in real construction environments. Have you ever been on a project where the final result looked exactly like the first day's blueprint without a single dollar of cost overrun? In the built environment, that is a rare unicorn. Welcome to our deep dive into change order management, process, governance, and claims avoidance. This session is a cornerstone of the PMI-CP curriculum because it addresses the volatile nature of construction where the only constant is change. We aren't just talking about shifting a wall or changing a paint color. We are talking about mastering the entire life cycle of scope changes. This involves understanding how a change is born, how it is priced, and how we ensure it stays within the bounds of contractual compliance. Whether you are an owner, a contractor, or a project manager, the way you handle these modifications determines whether the project is a financial success or a legal nightmare. First, we will look at the pricing mechanisms, the how of the money, and then we will move into the governance structures that keep the project on track. By the end of this module, you should feel confident in navigating the complex waters of the built environment's change protocols. This matters because a well-managed change order is a sign of a professional project, while a poorly managed one is an invitation for a claim. Let's begin by setting our specific targets for this session. What is the difference between a project manager who is busy and one who is effective? Usually, it comes down to their mastery of the process. Our first objective today is to help you differentiate between change types. Specifically, we will distinguish between directive and constructive change orders. This isn't just a theoretical exercise. It is a critical distinction for the PMI-CP exam and for your daily risk management. Next, we will master the process itself. We will navigate the 5-step change order management process, moving from the initial identification all the way to updating the final project records. Understanding the sequence is vital because, in a high-stakes environment, doing the right thing in the wrong order can still lead to a rejected claim. Thirdly, we'll look at pricing logic. You'll learn to select the correct mechanism, whether that's a lump sum, time and materials, unitary, or even a zero-cost change, based on how clearly the scope is defined. Following that, we will execute governance. We'll discuss authority limits and the appropriate use of construction change directives, or CCDs. These are powerful tools that allow work to continue even when parties don't agree on the price. Finally, a quick exam note. The PMI-CP focuses heavily on what do you do next scenarios. Pay close attention to the sequence of the 5-step process we are about to cover. Knowing the steps is good, knowing the order is what passes the exam. Let's start by looking at why change orders happen so frequently in the first place. Is a change order always a sign of failure? Not necessarily, but it is always a deviation. By definition, a change order is a formal modification to the contract. It can be an update, an addition, or even a deletion. Essentially, if it changes the original scope, the schedule, or the price, it requires a formal change order. Statistically, these are not minor occurrences. On average, change orders result in an 11% to 15% increase in project costs. That is a massive margin that can easily wipe out a project's contingency. These modifications generally fall into two categories: additive, which increases the work in terms of price or time, and deductive, which reduces the scope and results in a credit or price reduction. But we need to look deeper at the why. A major root cause we focus on is the low bidding trap. Imagine a contractor who submits an incredibly low bid with a negative margin just to win the work. Their strategy isn't efficiency, it's recovery. They intend to use aggressive change orders later in the project to recover their profit. This turns the construction phase into a constant negotiation battleground. As a project manager, your action here is critical. This is a primary procurement risk. You must perform a rigorous scope review during the bidding phase to ensure the numbers are realistic. If you don't catch the low bid early, you'll be dealing with project cost overruns later as the contractor tries to climb out of that negative margin hole. Now that we understand the motivation, let's look at the two primary ways these changes are initiated. If an owner asks for a different lobby tile, is that the same as finding an unmapped utility line? Contractually, no. We categorize these into directive and constructive changes. A directive change order is straightforward. It is initiated by the owner or the owner's representative. It is an explicit instruction to add or delete scope. Because the owner is saying, "I want this," these are typically low conflict, provided everyone can agree on the price. The flow is simple. Owner gives an instruction, and the contractor executes. However, the constructive change order is where things get complicated, and this is of high importance for your exam. In a constructive change, the owner didn't necessarily ask for the change, but circumstances or owner inaction force the contractor to modify the work. It's constructed out of necessity rather than a formal order. Think about these common scenarios. Perhaps the drawings were deficient or the specifications were wrong. Maybe the contractor encountered differing site conditions, like hitting unexpected rock where soil was promised. It could even be caused by an owner's representative being overly aggressive in inspections or giving undocumented verbal instructions. In these cases, the contractor is doing extra work without a formal piece of paper in hand. This often leads to claims and disputes. Understanding which type you're dealing with is the first step in determining how you'll pay for it. How do we decide what a change is worth? We don't just guess. We use specific pricing mechanisms. The clarity of the scope definition is what determines which mechanism you should use. First, we have the lump sum. This is our preferred method when the scope change is easily quantifiable. If you can count it, measure it, and put a fixed price on it, you use a lump sum. It's clean. and it includes the cost plus whatever markups or credits are agreed upon. It provides the most price certainty for the owner. But what if you don't know how much work is required? That's where time and materials, or T&M, comes in. This is used when the scope is difficult to quantify upfront, like repairing a leak where you don't know the extent of the damage until you open the wall. Because T&M is open-ended, it requires strict governance. The contractor must provide detailed labor and material logs that are verified daily by the owner to prevent bill padding. Next is the zero-cost change. These are modifications that change the nature of the work, but not the contract value. For example, swapping one type of material for another of equal price. Even though no money changes hands, you must still document these to ensure the as-built records are accurate. Finally, we have unitary cost. These are based on predetermined rate schedules already in the contract. Think X per cubic yard of concrete or Y per linear foot of pipe. This is highly efficient because the price is already negotiated. You just have to measure the quantity. To see how these play out in the real world, let's look at a sample exam scenario. Let's test your knowledge with a scenario you might see on the PMI-CP exam. Imagine a contractor is excavating a foundation and suddenly hits a massive rock formation. They check the geotechnical report provided during the bid phase, and the rock isn't shown there. The site manager walks over, looks at the rock and says, "Yep, that's rock." But they don't give a formal written instruction to change the work. The contractor, wanting to keep the project on schedule, rents specialized drilling equipment and continues. Later, they submit a claim for those rental costs. How should you, as the project manager, classify this claim? The answer is B, a constructive change order. Let's look at the logic. It cannot be a directive change because the owner never issued an explicit written request to change the scope. It wasn't a unitary cost application because no preset rate was triggered by a formal order. Instead, the change was forced by the differing site conditions, the unexpected rock, and the implied necessity to complete the foundation to finish the project. This is a classic constructive change. The contractor was forced to act because of a site reality that didn't match the contract documents. Understanding this classification is key to the next step, following the management process. Now we enter the heart of the module, the 5-step management process. You cannot manage changes effectively if you don't know the rule book. Step 1 is reviewing the contracts. Before you do anything else, you must check the change clause to see the specific process for determining new value. You also need to check the contractor's notice clause. This tells you the timeline requirements. If a contractor waits 3 weeks to tell you about a change that happened on day 1, they might have already forfeited their right to a claim. Step 2 is to identify the change and create a PCO, or potential change order file. The action here is to create this file immediately. A common mistake is waiting to see if the claim is valid before starting the paperwork. No, create the file the moment you suspect a change might be coming. Keep a close eye on the connection between requests for information, RFIs, and PCOs. An RFI is usually a technical clarification, but if the answer to that RFI changes the scope, it must immediately trigger a PCO. Always track your RFIs carefully. They are the breadcrumbs, or evidence often used to justify constructive changes later. If you aren't logging these immediately, you're losing control of the project's financial narrative. Speaking of the notice clause we just mentioned, let's look at why it's a major trap for the unwary. On the PMI-CP exam, there is a recurring trap that catches many experienced professionals. It revolves around the contractor's notice clause. This clause is the project's stopwatch. It dictates exactly how much time a contractor has to notify the owner of a potential change and the specific method they must use. For example, if an event occurs on day 0, the contract might require written notice within 24 or 48 hours. Here is the situation you'll likely face in an exam question. A contractor performs work that is clearly necessary and adds value to the project, but they submit the paperwork 2 weeks late. The contract explicitly required notice within 24 hours. What is the result? In a high governance environment, the claim is likely forfeited. This can feel unfair, but you must remember this key takeaway. In PMI-CP questions, procedural compliance, the time bars, often overrides the technical validity of the work itself. As a PM, you aren't just managing bricks and mortar, you are managing the clock. If the procedure isn't followed, the money doesn't flow. This strict adherence to the contract is what separates professional management from handshake deals. Once notice is properly given, we move to evaluation. Once a potential change order is logged, we have to evaluate it. This isn't just about looking at a price tag, it's a two-part investigation. First, we must establish entitlement. This is the yes or no phase. Does the contract actually allow for this extra cost? Is this work truly extra? Or could it have been reasonably inferred from the original scope? If the contractor should have known the work was required based on standard industry practice or the existing drawings, there is no entitlement. If and only if entitlement is established, we move to measure the effect. This involves two sub-steps: calculating the direct costs, how much for labor and materials, and performing a schedule analysis to see the time impact. A great tool for this is A3 problem solving. This is a one-page report format that helps you visualize the impact on quality, time, and budget all at once. It's designed to prevent the snowball effect, where a small change in one area causes unintended massive consequences in another. By using a structured tool like A3, you ensure that your evaluation is based on data, not just a gut feel. But what happens when the owner and contractor can't agree on that data? That brings us to step 4. When an owner reviews a PCO, the process usually takes one of two paths. In a perfect world, path A, the owner approves the PCO, a formal change order is issued, and the contract value is updated. Everything is documented and work proceeds. However, in reality, we often face path B, a dispute on price. Negotiation stalls, but the work is on the critical path. If you wait until the price is settled, the whole project might be delayed by weeks, costing thousands in liquidated damages. What do? You use a construction change directive, or CCD. A CCD is a unilateral order from the owner. It basically says, do the work now. We will argue about the price later. This is also known as force account work. Because it's a unilateral power, it should only be used as a last resort to prevent critical path delays. It protects the schedule while deferring the financial dispute to a later date. This is a high governance tool that ensures the project doesn't grind to a halt just because two people can't agree on a number. Let's look at how this applies to a common exam question. Here is a classic governance scenario. A design omission has been discovered, and it has halted work on the critical path. Both the owner and the contractor agree the work is necessary, but they are $50,000 apart in their cost estimates. To make matters worse, every day of delay costs the project $10,000. What is the most appropriate immediate action for the owner? If you choose to suspend work until the negotiation is done, you're losing $10,000 a day. If you pay the contractor's full price just to avoid conflict, you're abandoning your fiscal responsibility. The correct answer is B, issue a construction change directive. Why? Because the cost of delay is too high to wait for a negotiation. A CCD allows the work to proceed immediately, protecting the project's timeline. The pricing dispute is pushed to a force account process where actual costs can be tracked and audited later. This scenario perfectly illustrates the "what do you do next" focus of the exam, prioritizing project progress through formal governance tools. We've reached the final step of the process. Step 5, update records. In the world of construction claims, documentation isn't just paperwork, it is your primary defense. If you end up in court or an audit, your logs are the only things that matter. You must maintain 3 essential logs. First, the PCO log, which tracks the status of every potential change. Is it pending, approved, or rejected? Second, the RFI log, which tracks all technical clarifications. And third, the contract documents log, which tracks the current revision status of every drawing. You don't want a subcontractor building off revision 2 when the current version is revision 5. The gold standard here is to use a centralized platform, a single source of truth, so everyone is looking at the same data. At the end of the project, don't just file these away. Perform a lessons learned review. If you see that you are consistently underestimating soil issues, you can adjust your bidding process for the next project. Remember the golden rule of project management. If it isn't written down, it didn't happen. This matters because verbal agreements are unenforceable and disappear the moment someone leaves the project. Now that we know how to manage changes, let's talk about how to stop them from happening in the first place. The best way to manage a change order is to prevent it. Ambiguity is the enemy of your budget. Prevention starts with a clear scope of work. A good SOW doesn't just list what the contractor will do, it must explicitly list the exclusions, what they will not do. This closes the gap where most extra work claims are born. Next, use collaborative design. Why wait until construction to find out a detail is unbuildable? Involve downstream stakeholders like subcontractors and general contractors early in the design phase. They can spot unconstructible details that a designer might miss at a desk. You should also implement rigorous quality control through independent design reviews before the drawings are issued for construction. One of the most common causes of change orders is a lack of interdisciplinary coordination. This is solved by overlay checks, making sure the plumbing pipes actually connect to the civil storm drains, or ensuring that a structural beam isn't running right through a planned HVAC duct. A few hours of coordination in the office can save weeks of rework and thousands of dollars in the field. As we prepare to wrap up, let's look at the specific order of operations for the exam. If you are asked what to do first when a change is identified, the answer is almost always consult the contract. You must check the change clause and notice requirements before you take any other action. Step 2. Create the PCO file. The mantra here is log it before you solve it. Documentation starts the moment the risk is identified, not after it's been fixed. Step 3. Quantify the impact. You must analyze the schedule and cost using data. The exam will try to trick you with answers that rely on gut feel or expert opinion alone. Always look for the answer that involves formal analysis. Step 4. Formalize. If a verbal instruction was given, confirm it in writing immediately. Here's the biggest exam trap. Avoid any answer that suggests an informal agreement or a handshake deal. Even if the characters in the exam scenario are friends or have worked together for years, the exam assumes a high governance environment. In the world of the PMI-CP, if it's not formal, it's not the right answer. We've covered a lot of ground today. Let's summarize the key takeaways you'll need for both the exam and your professional practice. First, know your change types. A directive change is an order. A constructive change is a reality forced by circumstances. Second, choose your pricing wisely. Use lump sum when you have clarity, and use time and materials when you don't. But remember that T&M requires much stricter oversight. Third, remember that governance is your shield. The notice clause determines whether a claim is even valid, and the construction change directive is your break glass in case of emergency tool to keep the project moving during a dispute. Finally, always follow the 5-step process and keep your logs updated to maintain a clear audit trail. As we prepare to wrap up, let's look at the specific order of operations for the exam. If you are asked what to do first when a change is identified, the answer is almost always consult the contract. You must check the change clause and notice requirements before you take any other action. Step 2. create the PCO file. The mantra here is, log it before you solve it. Documentation starts the moment the risk is identified, not after it's been fixed. Step 3. Quantify the impact. You must analyze the schedule and cost using data. The exam will try to trick you with answers that rely on gut feel or expert opinion alone. Always look for the answer that involves formal analysis. Step 4. Formalize. If a verbal instruction was given, confirm it in writing immediately. Here is the biggest exam trap. Avoid any answer that suggests an informal agreement or a handshake deal. Even if the characters in the exam scenario are friends or have worked together for years, the exam assumes a high governance environment. In the world of the PMI-CP, if it's not formal, it's not the right answer. We've covered a lot of ground today. Let's summarize the key takeaways you'll need for both the exam and your professional practice. First, know your change types. A directive change is an order. A constructive change is a reality forced by circumstances. Second, choose your pricing wisely. Use lump sum when you have clarity, and use time and materials when you don't. But remember that T&M requires much stricter oversight. Third, remember that governance is your shield. The notice clause determines whether a claim is even valid, and the construction change directive is your break glass in case of emergency tool to keep the project moving during a dispute. Finally, always follow the 5-step process and keep your logs updated to maintain a clear audit trail. As the quote on the slide says, effective change management isn't just about processing paperwork. It's about protecting the project's baseline and profitability. When you master these tools, you move from being a reactive manager to a proactive leader. Welcome to this essential session of your PMI-CP exam preparation. Have you ever wondered why some projects, despite having a clear start, seem to drift into never-ending cycles of additions and budget overruns? Often, the culprit isn't a lack of effort, but a failure in managing boundaries. Today, we are diving deep into scope governance and technology, focusing specifically on how we manage boundaries, optimize value, and measure performance throughout the project lifecycle. In the world of construction and large-scale capital projects, scope is your foundation. If the foundation is shaky or poorly defined, every subsequent layer, from procurement to execution, will suffer. This course is designed to move beyond the theory of scope and into the practical governance required to keep a project on track. We will look at the tools and technologies that allow us to move from reactive management to proactive leadership. This matters because as a project manager or lead, you aren't just a taskmaster. You are the guardian of the project's value proposition. By the end of this module, you will understand how to use governance frameworks to protect your project from unauthorized changes while using performance metrics to provide an honest, data-driven picture of your progress. Let's start by looking at exactly what we intend to achieve in this session as we review our primary learning objectives. What separates a project that finishes successfully from one that collapses under its own weight? It usually comes down to these 5 pillars of mastery. First, we must learn to differentiate between scope creep and scope change. On the surface, they might look similar. Both involve more work, but one is a managed process, while the other is a process failure. For your exam, identifying which is which in a scenario is vital for choosing the correct management response. Next, we move into the math of project health, earned value management, or EVM. We aren't just looking at how much money is spent, but what value that money actually bought. You will learn to analyze indices like the Schedule Performance Index, SPI, and Cost Performance Index, CPI, to diagnose project health. Following that, we will explore value engineering, or VE. This isn't just about cutting costs. It's about optimizing function. We will practice the active verb plus measurable noun logic that is the hallmark of professional VE analysis. Our fourth objective covers target value delivery, or TVD. This represents a massive shift in industry thinking, moving from the traditional cost-to-design model to a design-to-cost mindset. Finally, we will discuss scope governance. We need to determine who has the authority to say yes or no to a change. Without clear thresholds and authority levels, decision-making becomes a bottleneck. Now that we have our roadmap, let's look at how scope management evolves across the different phases of a project's lifecycle. The golden rule of scope management is simple to state, but difficult to execute. You must ensure the project includes all the work required and only the work required. Think of it as a protective bubble around your project. Anything outside that bubble is a distraction that drains resources. To master this, we have to look at how scope management shifts as we move from planning to handover. In the front-end planning or FEP phase, the criticality is at its highest. This is where the project is won or lost. If your requirements are inaccurate or poorly defined here, you face a massive risk of downstream failure. To combat this, we use tools like the PDRI, the Project Definition Rating Index, which provides a structured method for measuring how well a project scope is defined before it moves to execution. As we transition into the execution phase, the pressure changes. Now, you are dealing with special feature requests from stakeholders. There is a human element here: mental fatigue. When a team is tired, they are more likely to agree to unauthorized changes just to keep a stakeholder happy. Finally, in the handover phase, your job is verification. You must verify the final product against the original scope of services to prevent scope bloat or last-minute additions that weren't paid for. This lifecycle perspective sets the stage for our next topic: the crucial distinction between managed change and unmanaged creep. If there is one concept you must master for the PMI-CP exam, it is the difference between scope change and scope creep. These are not just different terms. They represent the difference between a project under control and a project in chaos. Let's look at scope change first. This is a managed process. It originates from a formal request and strictly follows your change order management process. Crucially, when a change order is approved, the project baseline is replanned. This means your schedule and budget are officially adjusted to reflect the new reality. Now, compare that to scope creep. Creep is unmanaged and often sneaky. It starts with informal requests, ambiguous requirements, or what we call gold plating, where a team member adds extra features they think the client will like without being asked. Because it bypasses the formal approval process, the work is squeezed into the existing baseline. The result? Your margins erode, your schedule slips, and the team gets burned out. Here is the key exam pattern to remember. Ask yourself, did the baseline change? If the baseline was officially updated to accommodate the work, it's a scope change. If the work increased but the baseline remained the same, you are looking at scope creep. Understanding this logic is the only way to answer scenario-based questions correctly. Speaking of scenarios, let's look at a classic example involving a helpful engineer. Let's walk through a scenario you are very likely to encounter in some form on the exam. Imagine you are the project manager for a commercial complex. During a site walk, your client points to a lighting fixture and mentions they'd prefer a more expensive model than what was originally specified. Your site engineer, wanting to build a strong relationship and be helpful, immediately agrees, saying, "No problem, it's a quick installation anyway." What is the conflict here? Even though the engineer meant well, they just committed to work outside the project baseline without performing any impact analysis. This is a textbook governance failure. When presented with options like stopping the work, issuing a formal change order, or allowing it as a value add, what is the correct path? The correct action is always to issue a formal change order request for the cost difference before proceeding. Why? Because allowing the swap without a formal process is actually gold plating. Governance dictates that every change, no matter how small it seems, requires a formal assessment of how it affects the project. Remember, client satisfaction is important, but it does not override the contract or the legal project baseline. To understand why this is so critical, we need to revisit the iron triangle of project management. The triple constraint, often called the iron triangle, is the fundamental law of project physics. It consists of scope, cost, and time, with quality sitting right in the center. The iron in the name is there for a reason. These boundaries are rigid. The core logic you must memorize is that you cannot change one of these constraints without impacting at least one of the others. Let's look at how this plays out in real-world governance. If you have a fixed scope and the client decides to add more requirements, the triangle must expand. That means either your cost must go up to pay for it, or your time must increase to build it, usually both. If you are working with a fixed budget and costs start to rise elsewhere, you only have two options. You either have to cut the scope or find a way to finish in less time. Finally, consider a fixed schedule, like a stadium that must be ready for an opening ceremony. If you fall behind, you either have to throw more money at the problem by adding resources, or you have to decrease the scope. As a PM, your job is to balance these three. When they get out of alignment, we need a way to measure exactly how far off track we are. That is where earned value management comes in. Earned value management, or EVM, is the primary tool we use to integrate scope, schedule, and cost into a single health metric. Without EVM, you might know you've spent 50% of your budget, but you won't know if you've actually finished 50% of the work. To understand EVM, you need to master three core data points. First is PV, or planned value. This is your baseline. It represents what you plan to have finished by this point in time. Second is AC, or actual cost. This is simply the amount of money you have spent so far. The magic happens with the third metric, EV, or earned value. This is the budgeted cost of work performed. It tells you the value of the work that is actually done. When we compare these, we get our variances. Schedule variance, or SV, is EV minus PV. If the result is negative, you are behind schedule. Cost variance, or CV, is EV minus AC. A negative result here means you are over budget. Look at the graph on the slide. When the actual cost line is above the earned value line, and the planned value line is also above the earned value line, you are in the danger zone, behind schedule and over budget. Now let's look at how we turn these variances into indices for easier comparison. Variances are great for knowing how many dollars you are off, but indices, SPI and CPI, are better for understanding the rate of efficiency. The Schedule Performance Index, or SPI, is calculated by dividing earned value by planned value. It tells you the percentage of the planned rate at which you are progressing. If your SPI is 0.8, you are only working at 80% efficiency compared to your plan. Any number less than 1.0 means you are behind schedule. The Cost Performance Index, or CPI, is perhaps the most important metric in project management. It is EV divided by AC. It tells you how much value you are getting for every dollar spent. A CPI of 0.89 means that for every dollar you spend, you are only getting 89 cents of value. Like SPI, a CPI below 1.0 means you are over budget. We also use these to look into the future. The EAC, or Estimate at Completion, helps us forecast what the final bill will be, calculated as your total budget at completion divided by your current CPI. Finally, there's the TCPI, or To Complete Performance Index. This tells you the level of efficiency your team must achieve from this point forward if you want to finish the project within the original budget. Let's put these formulas into practice with a realistic exam-style data set. On the exam, you will likely see a table of data and be asked, what should the PM do next? Let's look at this data board. We have a planned value of $100,000, an earned value of only $80,000, and an actual cost of $90,000. Doing some quick mental math, we see that our schedule variance is negative $20,000. We are significantly behind. Our cost variance is negative $10,000. We are over budget. and our CPI is roughly 0.89, meaning we are inefficient. So, what is the best course of action? The exam might offer tempting options like report that the project is on track because the gap is small, or immediately cut the scope to save money. However, the most appropriate action is to analyze the critical path and high-cost work packages to find the root causes of the inefficiency. Variances are great for knowing how many dollars you are off, but indices, SPI and CPI, are better for understanding the rate of efficiency. The Schedule Performance Index, or SPI, is calculated by dividing earned value by planned value. It tells you the percentage of the planned rate at which you are progressing. If your SPI is 0.8, you are only working at 80% efficiency compared to your plan. Any number less than 1.0 means you are behind schedule. The Cost Performance Index, or CPI, is perhaps the most important metric in project management. It is EV divided by AC. It tells you how much value you are getting for every dollar spent. A CPI of 0.89 means that for every dollar you spend, you are only getting 89 cents of value. Like SPI, a CPI below 1.0 means you are over budget. We also use these to look into the future. The EAC, or Estimate at Completion, helps us forecast what the final bill will be, calculated as your total budget at completion divided by your current CPI. Finally, there's the TCPI, or To Complete Performance Index. This tells you the level of efficiency your team must achieve from this point forward if you want to finish the project within the original budget. Let's put these formulas into practice with a realistic exam-style data set. On the exam, you will likely see a table of data and be asked, what should the PM do next? Let's look at this data board. We have a planned value of $100,000, an earned value of only $80,000, and an actual cost of $90,000. Doing some quick mental math, we see that our schedule variance is negative $20,000. We are significantly behind. Our cost variance is negative $10,000. We are over budget. And our CPI is roughly 0.89, meaning we are inefficient. So, what is the best course of action? The exam might offer tempting options like report that the project is on track because the gap is small, or immediately cut the scope to save money. However, the most appropriate action is to analyze the critical path and high-cost work packages to find the root causes of the inefficiency. Why is this the answer? Because before you can fix a problem, you must diagnose it. Are the delays due to weather, labor shortages, or poor planning? Reporting the project as on track when the data shows otherwise is not just bad management. It's unethical and a violation of professional standards. Diagnosis leads to better solutions, such as value engineering, which we will discuss next as a way to optimize the project's function. A common misconception in our industry is that value engineering, or VE, is just a fancy term for cost cutting. That is incorrect. VE is actually about optimizing function. Think of value as a ratio. Value equals function divided by cost. You can increase value by lowering the cost for the same function, or by increasing the function for the same cost. The heart of VE is functional analysis. To do this correctly, you must follow a strict rule. Define every item using an active verb and a measurable noun. For example, instead of saying you need a wall, which is just an object, you define the function as separate space. Instead of saying you need a steel beam, the function is to support load. Why does this matter? Because when you define a wall, your mind is already biased toward bricks or drywall. But when you define the function as separate space, you open the door to creative alternatives like glass partitions or modular panels that might be cheaper or more effective. By removing bias, you allow for true innovation. To make this happen, we follow a structured 6-phase approach called the VE Job Plan. Value engineering isn't a one-off brainstorming session. It is a rigorous 6-phase process called the job plan. It begins with the information phase, where we gather all necessary project data. We then move to functional analysis, where we define those verb-noun pairs we just discussed. Only after we understand the functions do we move to the creative phase to brainstorm alternatives. Once we have a list of ideas, we enter the evaluation phase, where we filter those ideas for feasibility. Can we actually build this? Is it safe? The survivors move to the development phase, where we work up formal proposals including cost-benefit analyses. Finally, we reach the presentation phase, where we present our findings to the decision makers. There is a critical takeaway regarding timing here. Look at the arrow for life cycle effectiveness. VE is most effective when done early in the project. As the project progresses and designs are finalized, the cost to change things increases, leading to diminishing returns. This early focus mindset is also the driving force behind our next topic, target value delivery. Target value delivery, or TVD, represents a fundamental shift in how we approach construction costs. In the traditional model, we design something, then we estimate what it will cost. And if it's too expensive, we have to go back and redesign. This is inefficient. TVD flips this on its head. Cost becomes an input to the design process. We design to cost, rather than costing a design. To understand TVD, you need to know three terms. The allowable cost is the absolute ceiling. It's the maximum amount the client can pay for the project to be viable. The market cost is what the project would typically cost based on historical data. Our goal is the target cost, which is set lower than the market cost to drive efficiency. The space between what it usually costs and what we want it to cost is the innovation gap. To close that gap, we need heavy collaboration. TVD works best with integrated project delivery, IPD, and big room collaboration, where owners, designers, and contractors all work in the same space to solve problems in real time. While TVD and VE might seem similar, they serve different primary purposes. Let's compare them side by side. Because VE and TVD both deal with value and cost, learners often confuse them. However, for the exam, you must distinguish between them based on their focus, mechanism, and timing. The primary focus of value engineering is optimizing function, getting the best performance for the price. Target value delivery, on the other hand, is focused on staying within a specific cost limit from day one. Their mechanisms are also different. VE relies on functional analysis, that verb-noun logic we practiced. TVD relies on continuous estimating and big room collaboration to ensure the design never exceeds the target cost. Think of VE as a scalpel used in discrete workshops at specific milestones, while TVD is like a continuous heart monitor that stays on throughout the entire design phase. Ultimately, the goal of VE is the ratio of value equals function over cost. The goal of TVD is much simpler, ensuring that the expected cost remains lower than the allowable cost. Whether you are using VE or TVD, you need a strong governance structure to make sure decisions are actually made and enforced. Governance is the framework of who decides what. Without it, projects get stuck in analysis paralysis. At the top of the pyramid is the owner. They have the ultimate responsibility for the project's boundaries and budget. They are the final decision makers. To prevent the owner from becoming a bottleneck, we use a governance board or steering committee. They typically handle approvals for changes that exceed a specific financial threshold. For example, anything over $10,000. This allows the project manager to keep the project moving. It's important to note that while the PM manages the process of change, they usually have very limited authority to actually change the project's boundaries themselves. For successful governance, you need three things: defined thresholds, which clearly state who can approve what amount, a single lead agency, especially in public projects where multiple government departments might be involved, and a clear audit trail. This audit trail is your protection. It proves that every change was analyzed, approved, and documented. This becomes especially important when you are dealing with multiple stakeholders with competing interests. Here is another classic exam scenario: Imagine a government infrastructure project where 3 different agencies are involved. Agency A wants the project done at high speed. Agency B is obsessed with high quality. Agency C just wants the lowest possible cost. They are providing conflicting requirements, and as the PM, you find yourself unable to finalize the project baseline. What do? The exam might suggest averaging the requirements or just following the agency that provides the funding. But the correct professional response is to escalate the issue to the governance board and request that they designate a lead client. Why? Because as a PM, you do not have the political authority to resolve structural conflicts between different government agencies. Governance exists specifically to align these goals. For a project to succeed, there must be a single, unified decision-making voice, a lead client, who has the final word when interests clash. Trying to please everyone usually results in pleasing no one. As we approach the end of this module, let's address some of the most common misconceptions that trip up candidates on the PMI-CP exam. First, remember that VE is not just cost-cutting. In fact, value engineering can actually justify an increase in cost if it significantly increases the function or long-term value of the asset. Second, don't fall for the trap that scope creep is inevitable. Change is inevitable because projects are complex, but creep, unmanaged, unapproved change, is a failure of management. A disciplined PM can prevent creep through strict governance. Third, project management isn't a zero-sum game where one person's gain is another's loss. In modern frameworks like TVD and IPD, the goal is to expand the pie through collaborative efficiency. Finally, let's be very clear about ethics and data. If your SPI is 0.9, you are not on schedule. Reporting that you are on track when the indices show otherwise is a misrepresentation of facts. Always let the data tell the truth. Now let's summarize the key takeaways you need to carry into your exam and your daily practice. We have covered a lot of ground today, from the rigid boundaries of the triple constraint to the creative possibilities of value engineering. To wrap up, remember these 4 pillars. For scope control, your primary job is to protect the project from scope creep. You do this by ensuring every change follows a formal change order process. For performance, you now have the tools, CPI and SPI, to look past the raw numbers and see the true efficiency of your project. Use these metrics to provide honest, data-driven updates to your stakeholders. When it comes to optimization, remember that value engineering isn't about making things cheaper. It's about making them better through functional analysis. Combine that with target value delivery to ensure you are designing within the client's allowable cost. Finally, never forget the importance of governance. Establish clear authority thresholds early on so everyone knows who can sign off on what. You, as the PM, are the master of the process, but the owner always remains the master of the scope. Master these concepts, and you will not only be ready for the PMI-CP exam, but also for the complex challenges of modern project leadership. Have you ever wondered why some projects seem to be in a state of constant legal battle while others flow smoothly from inception to handover? Often the difference isn't the quality of the engineering, but the strategy behind the contract. Welcome to Lecture 13 of your Construction Professional Certification Prep. Today, we are diving deep into contract life cycle strategy and management. This isn't just about reading the fine print after a problem occurs. Professional contract management is a continuous circular process, just like the diagram you see here. It starts long before a shovel hits the ground and continues long after the ribbon is cut. In the world of the PMI-CP exam, understanding this cycle is the key to transitioning from a traditional project manager to a strategic construction leader. First, we will look at how the contract lifecycle integrates with your daily operations. Next, we will explore why a strategy-first approach is essential for protecting your project's margin and your organization's reputation. This matters because a contract is more than a legal shield. It is the roadmap for the entire project delivery. By the end of this session, you'll see the contract not as a static document sitting in a drawer, but as a dynamic tool that guides every decision you make. Now let's look at exactly what the exam expects you to master in this module. What is the most critical next step when a client suddenly changes the project scope? If you aren't sure, the PMI-CP exam will likely catch you off guard. Our objectives today are strictly aligned with the exam's focus on identifying the correct sequence of actions in a project's life. First, we are going to learn how to differentiate between the 5 fundamental stages of a contract: discovery, pre-award, proposal, execution, and closeout. You'll need to know exactly which stage you are in to make the right choice. We'll also tackle a high-level concept, the walkaway point. This is the threshold where the risk simply isn't worth the reward. For an engineer or PM, knowing when to say no is just as important as knowing how to build. Next, we will break down the technical differences between a request for tender, RFT, and a request for proposal, RFP. This selection depends entirely on design maturity, essentially how finished your drawings are before you go to market. We will also look at linguistic precision. In the legal world, words like must and may are worlds apart. One is a mandatory obligation, while the other is a discretionary right. Finally, we'll focus on the governance of change management. The exam specifically tests your ability to resolve disputes by adhering to strict contract clauses and distinguishing between risk allocation, who owns the risk, and risk mitigation, how we reduce it. This foundation will prepare you for the complex scenarios you'll face on exam day. Let's start by visualizing the entire framework. Imagine building a skyscraper without a foundation. That is exactly what it's like to manage a project without a structured contract framework. As we look at this 5-stage model, notice the note at the bottom. This cycle runs parallel to the project delivery cycle. They are intertwined, but they focus on different things. We begin with stage 1, discovery. This is the "is this a good idea" phase. We look at feasibility and build a business case. Stage 2 is pre-award, where we decide our strategy. Are we doing design build or a traditional method? We also prepare our risk documentation here. Stage 3 is the proposal process. This is where the market gets involved through solicitation, bidding, and our evaluation of those bids. Once a winner is selected, we move into stage 4, execution and management. This is the meat of the project where we track performance and manage changes through strict governance. Finally, we reach stage 5, contract closeout. This is often the most neglected phase, but it is where we handle handovers, warranties, and that all-important final payment. This matters because if you skip a step, for example, if you go to the proposal stage before you've finished your risk documentation and pre-award, you are walking into a trap. Each stage provides the necessary information for the one that follows. Now, let's zoom in on stage 1 and talk about the point where you might decide to walk away entirely. What is the most expensive project your company could ever take on? Often, it's the one you should have never bid on in the first place. This is where stage 1, discovery, comes in. It's a period of intense screening and feasibility analysis to ensure a project aligns with your strategic goals. If you are an owner, your focus here is on the business case. You're asking about return on investment, ROI, and benchmarking the project against the current market to see if it's realistic. If you are a contractor, you are screening the opportunity. You're looking at the client, the location, and the technical requirements to see if they fit your expertise. Now look at the graph on the slide. This represents one of the most critical exam concepts, the walkaway point. As the project phase moves forward, the risk level typically increases while the margin or potential profit might stay flat or even decrease. The threshold is a horizontal line representing your company's maximum risk tolerance. The red X is the walkaway point. You must define this point before you commit capital. Ask yourself, is the complexity beyond our current capability? Is the profit margin large enough to cover the what-ifs? If the risk line crosses your threshold, the professional move is to walk away. This isn't a failure, it's a governance rule that protects the firm. To see how this works in a real scenario, let's look at a discovery phase problem. Let's put you in the hot seat. You are a director at a construction firm looking at a massive mega project. During the discovery phase, you find two red flags. The client doesn't have a clear funding structure yet, and the site has unmapped geological risks. To make things harder, your firm is already highly leveraged, meaning you don't have much cash or bonding capacity to spare. What is your next move? The exam will give you choices that sound reasonable. You could increase your bid margin, option 1, to cover the risks, but you might still lose a lot of money if the project stalls. You could submit a qualified bid, option 3, but the client might throw it out. You could wait for the RFP, option 4, but that's being reactive. The best action is option 2. Offer a short-term feasibility study contract. Why? Because the PMI-CP values risk-based decision-making. By taking a small, separate contract to do the due diligence, you get paid to investigate the geological risks and wait for the funding to materialize. You aren't committing your whole firm to a billion-dollar risk. You're taking a calculated, professional step to gather more data. This rationale, protecting capital while seeking information, is a recurring theme in the exam. Once you have the information and decide the project is a go, you move to stage 2 to set your procurement strategy. Once the project passes the discovery phase, we enter stage 2, pre-award strategy. This is where we set the rules of engagement for the contract. This stage is built on 3 pillars. First is the delivery method. Are we going with design bid build, DBB, where the design is 100% done? Design build, DB, where one entity does both? Or maybe integrated project delivery, IPD, where everyone shares the risk? This decision is huge because it dictates exactly how the contract will be structured. Second is risk documentation. Before you ever ask a contractor for a price, you must document your risk appetite. What risks are you willing to take, and what risks do you want to transfer to the contractor? This must be written down before tendering begins. Third is the evaluation criteria. To be a professional, you need a rigorous scorecard. You shouldn't just pick the cheapest guy. You need to look at financial stability, their past performance, and their safety record, specifically their experience modification rate, or EMR. If a contractor has a bad EMR, they might be a huge liability on your site. The goal here is objectivity. You want a system that picks the best partner based on facts, not feelings. One of the most important decisions in this stage is whether to use an RFT or an RFP, and the exam has a very specific logic for this. Voice-over script. This slide is a cheat sheet for a guaranteed exam question. You need to know when to use a request for tender, RFT, versus a request for proposal, RFP. The deciding factor is design maturity. Imagine you are an owner. If your design maturity is high, meaning you have 100% complete blueprints, you use an RFT, you know exactly what you want, and you're asking suppliers to price this specific work. Your focus is on who can give you the best cost and follow the schedule most strictly. However, if your design maturity is low, meaning you just have a concept or a functional requirement, you use an RFP. You know the outcome you want, like, I need a bridge that carries 5,000 cars. But you don't know the best way to build it. You are asking the supplier to propose a solution. Here, you are paying for their innovation and their specific methodology. For the exam, look for keywords. If the scenario says the drawings are complete, that is a signal for RFT. If it says the owner is seeking alternative solutions or innovation, that is a signal for RFP. Getting this strategy right ensures that the next stage, the proposal process, is fair and effective. Stage 3 is the proposal process, where the project moves from your internal team to the open market. This process follows a very specific order: solicitation, an RFI, request for information period, submission, selection, and finally, contract formulation. The most important governance rule for the exam involves the RFI period. Let's say bidder A finds a mistake in your drawings and asks for clarification. If you only tell bidder A the answer, you've created information asymmetry. That is an unfair advantage, and it can lead to a bid protest that shuts down your project. The rule is, if you answer an RFI for one bidder, you must issue a formal addendum to every single bidder. When it comes to selection, professional PMs avoid the low bid trap. We've all seen it. A contractor bids extremely low just to get the job, but then they have no margin left to actually do the work safely or on time. Instead, you should select based on best value. Best value is a calculation that weights the price against other factors, like the contractor's safety record, their financial health, and their current capacity. You want to know, do they have the people available right now to actually finish my project? Once you've selected the right partner and formulated the contract, it's time to move into execution. We are now in stage 4, execution. This is where most projects succeed or fail, based on how well the contract is managed on a daily basis. Here is a practical reality. Your field supervisors and site engineers are probably not going to read a 200-page legal contract every morning. To bridge the gap between the legal office and the construction site, we use a laminated list, or a project cheat sheet. This is a one-page summary of the most critical notice provisions. For example, if the contract says a delay notice must be filed within 48 hours of an event, that needs to be on this list. You also want your safety protocols, scope boundaries, and major milestones clearly visible. You should post this in meeting rooms and common areas. Why? Because it enforces contractual awareness. If a site supervisor knows they only have 48 hours to report a problem, they are much more likely to pick up the phone. This prevents a small technical issue on site from becoming a massive legal dispute 6 months later because no one gave proper notice. Execution is all about following the rules of the game. And the most important rule of the game is knowing who actually has the power to change those rules. This is what we call governance. The client told me to just go ahead and move that wall, so I did. Those are some of the most dangerous words in construction. In stage 4, clear governance and change authority are your only defense against unauthorized scope creep. Every professional project should have delegated authority limits. As you see on the slide, a sponsor or owner might handle big changes over $50,000. A project manager might have authority for smaller changes. But look at the field supervisor. They have site execution only authority. They cannot, and should not, approve a change to the scope. The change control process must be a formal loop. You review the change, you approve it in writing, and you track its impact on the budget and schedule. There is no room for handshake deals. Here is a major exam tip. If a scenario describes a client giving a verbal instruction to a PM to change something, the correct action is never to just start the work. The correct action is to halt, document the request, and follow the formal change process. To do this effectively, you need to understand the specific language used in the contract clauses. In the world of contracts, words are like surgical tools. They must be used with precision. One of the most common causes of disputes is a misunderstanding of linguistic precision. If a clause says must or shall, it is a mandatory obligation. If you don't do it, you are in breach of contract. However, if it says may, it is discretionary. You have the right to act, but you aren't forced to. For example, the owner may inspect the work, means they can if they want to, but they don't have to. You also need to master the key clauses. Termination for cause means someone messed up, a default, whereas convenience means the owner can end the project for no reason at all, though they usually have to pay a fee. Indemnity is all about risk transfer. Who pays if a third party gets hurt? Liquidated damages are pre-agreed amounts paid if the project is late. They aren't penalties, they are compensatory. Finally, look at the dispute resolution ladder. You always start with negotiation. If that fails, you go to arbitration, a private judge. Only as a last resort do you go to litigation, public court. Understanding these clauses is what allows you to handle a delay claim without panicking. Let's look at a scenario that happens on almost every project. A contractor submits a claim for a 2-week extension because of unusually severe weather. The owner sends a quick email rejecting it, and now the contractor is threatening to stop work. What do? The exam will try to tempt you with soft answers. You might want to compromise, option 4, to keep the project moving, or you might want to escalate to arbitration immediately, option 3. But the best action is option 2. Review the force majeure and notice clauses for validity. Why? Because in contract management, contract adherence comes first. You need to check, does the contract actually define rain as a force majeure event? More importantly, did the contractor give timely notice? If the contract requires notice within 48 hours of the storm, and they waited 2 weeks, the claim is legally dead before it even starts. By sticking to the contract, you remove the emotion from the argument. It's not about being mean, it's about following the rules everyone agreed to. If the claim is valid, you grant it. If not, you have a solid basis for rejection. This leads us to our final stage, closeout. We are at the finish line. Stage 5, contract closeout. Many project managers make the mistake of thinking the project is done when the building is standing. But as the slide says, the project is not complete until the contract is closed. This is often the most neglected stage because everyone is tired and wants to go home. Closeout involves 4 major tasks. First is the punch list, or snag list. This is a final walkthrough to find every small defect, a scratched tile, a leaky faucet, and fix it. Second is the documentation handover. You must hand over the operation and maintenance O&M manuals, the warranties, and the as-built drawings that show where everything was actually installed. Third is final accounting. This is where you settle all outstanding change orders and finally release the retainage, or final payment. Fourth, and most importantly for your organization's future, is lessons learned. Did the contractor perform well? Were there clauses that caused too much friction? If you don't close the contract properly, you leave your company open to tail-end risks, like warranty disputes or unpaid claims that pop up years later. To avoid these headaches, let's look at the most common pitfalls you'll encounter. As we near the end of the module, let's talk about why projects fail. These 5 pitfalls are the monsters under the bed for every contract manager. Number 1 is poor scope definition. If the contract doesn't clearly say what is not included, you are going to have a dispute. Number 2 is ambiguous language. If you use shall when you mean may, or use vague words like reasonable, you are inviting a lawyer to argue with you. Number 3 is deal fever. This is when a company is so desperate to win a job that they ignore their own walkaway point. They take on a project with a risk profile that they simply cannot handle. Number 4 is the failure to track changes. This happens when you have handshake deals on site but no formal paperwork. Eventually, the money runs out and no one knows who owes what. Finally, number 5, siloed teams. This is when the legal department writes the contract, but the project manager never reads it. If the people building the project don't understand their legal obligations, the contract is just a piece of paper. To wrap up, let's look at the mindset you need to succeed. We've covered a lot of ground today. To succeed on the PMI-CP exam and in your career, you need to adopt the contract manager's mindset. First, be proactive. Do not wait for a crisis to read your contract. You should know your notice periods and your musts before day one. Second, be structured. Use the 5-stage framework we discussed. Discovery, pre-award, proposal, execution, and closeout. Each stage has a job to do. Third, be governance-driven. Respect the limits of authority. If you aren't authorized to sign for a 100K change, don't do it. Always insist on written notice. Fourth, be risk-aware. Use the walk-away point to protect your organization. No single project is worth risking the entire firm's stability. Remember, a well-managed contract isn't just a legal document. It is the roadmap to project success. It ensures that everyone knows their role, their risks, and their rewards.